Oh, very, very good. We have another night pass coming up, and I thought perhaps that we could do some more things if you think this is sensible. Other than that, we could, depending again of whether you have done any of the downward-looking things like the ocean photography and that kind of thing. If you think you have gotten enough data on this air glow, but I think this air glow could be run again because it's slightly different solar elevation angle, and you can be looking towards the terminator, which is of course with you all the time now. Over.
Yeah, I agree. It wouldn't hurt to do the air glow again. I'd like to get a few grading shots. I don't think we've got enough good grading pictures, so I could take a few of those. And if I can see the ocean, if I'm really not sure what we're going to be passing over on this next round, I could slip in 4,800 for that.
Okay, that sounds great, Owen. I think that would be very valuable for both things, and the grading would be extremely good if you could do that.
Yeah, Marshall Ops, Space Lab from the DS2.
Go ahead, Byron. We're listening.
Okay, Mike, a couple of miscellaneous things. Number one, I did the 101 video tape change out. That was completed 5 days, 1 hour, 50 minutes. And the reading on that tape was 802.
Okay, we copy that 101 tape change at 5 days, 1 hour, the tape reading being 802.
Do you want a quick downlink on the housekeeping data also?
Yes, please, Byron, that'd be great.
Hey, stand by.
Also, we need a command DPA, REL 14 op. That is REL 14, Oscar Papa.
Okay, Owen will be doing that, and for the 101 people, the left and right rotor speeds are 63.9. Rotor temp is 24.6, and dark box temp 24.0, and a key flex elapsed time of 108 hours, 26 minutes over.
Real good, Byron, we copy.
Now, just after I put that new tape in, there was a scheduled data take, so I confirmed that the tape did advance 3 units.
Terrific. Thanks very much.
Okay, and let's see. You guys want us routinely to issue a re-op of those routes if we get a skip message when we're LOS over?
No, I don't believe we want you to do that, Byron. We asked you to do that a couple times in the past, largely for testing purposes when we're AOS, but we don't want you to do that automatically.
Just wanted to clarify it.
Right. We have a message for you from the 028 team. Professor Scott and his colleagues. We're 5 seconds to LOS.
Yeah. Excuse me. We have a couple of minutes, yeah. We'll see you in 2 minutes, Byron.
We're here.
This is Marshall Space Lab Operations, 5 days, 2 hours, 13 minutes mission elapsed time. And we have loss of signal with Space Lab through Hawaii Ground Tracking Station. We're anticipating reacquisition of signal through tracking and data relay satellite in just under 2 minutes. During the upcoming pass, we're anticipating first some live television from the orbiter cargo bay cameras, Earth views, with Space Lab in the field of view, and this should be followed within a few minutes with a videotape dump of installation of the very wide field camera in the scientific airlock. This recorded earlier today, and that should be dumped within about 9 minutes after the conclusion of the live television from the orbiter cargo bay cameras. During this acquisition of signal, crews scheduled to continue their operations of space plasma physics experiments specifically Experiment 2, which Owen Garrett was discussing with AEPI co-investigator Steve Mendy during the last brief acquisition of signal. Standing by now for reacquisition of signal in just under a half minute.
And Space Lab Marshal Ops, we've got you for 51 minutes.
Okay, Bill. Bill, Marshal Ops, Space Lab, how do you read?
Loud and clear, Byron.
Okay, the one thing we didn't get to the last time was 022 status. We had the thing mounted on the table, the thing with the lovely, very wide-field camera, and during the last LOS we brought it back into the module. We confirmed the operation of all 4 filters. We confirmed the shutter operation as best we could, and we definitely could hear the film advance 2 or 3 times during the course of the checkout. And we also could verify that the right serial command was correct and the grading is in the field of view. Over.
Roger, we copy, and they're dancing under the Tour FL.
Real good, Byron. We copy.
Well, as long as it's good for bouillabaisse dinner in Marseille, we'll take it. And Owen has depressurized the sow, and we're in the final stages of that operation.
Okay, real good.
Byron Lichtenberg reporting good results on the checkout.
Space Lab, we're going to have some video.
Concurrently with...
Go ahead, Byron.
Go ahead, Bill.
Okay, we're going to have some live video of the Earth from your cameras. Go ahead, Byron.
Okay. You took... Okay, I was going to ask a question about this upcoming nighttime pass. It shows us running 19 Alpha along with API and CPAC, and obviously we'll be doing the image intensifier ops. Would 19 still like us to run it? We could stray electrons floating around up there, over?
Yes, this upcoming 19 run, I believe, is first and automatic, and no, first to manual and automatic, but I'm going to check back with them and see just how they want that choreographed. As I'm sure where we've deleted the 02 operations, what with the problems we've been having with the route, there'll also be no CPAC MTV operations there. Steve Mendy has already been in touch with Owen concerning the handheld intensifier studies, which he'd like Owen to do. But what I'll do is get with the 19 people and get back to you for experiment 19.
Okay, real good. You wouldn't believe the view out the top viewport window. Gorgeous.
That sounds great. And of course, you've already copied the fact that we're going to a Faust attitude at this upcoming night, and I think you have the timeline number and the time at which we'd like you to count it for us.
Now receiving live downlink television from Space Lab.
Bristol, where's our grid computer say we are right now? It's beautiful. Now, Michael, I guess we're coming over the west coast of the U.S., and we say hello to all the people down in Oregon.
That sounds great, Byron. Thanks for the report. We're getting some real-time video downlink. We're looking at the exterior Space Lab from the forward payload bay camera, and there's a gorgeous limb of the daylit Earth off behind the Space Lab module.
Roger that. There's a lot of good snow down in the mountains in Oregon. Ski season is fast approaching.
Hey, firm. We'll have to get together on that a little bit after the mission.
Absolutely right.
Experiencing a temporary dropout of the TV signal from the Space Lab payload bay cameras. Meanwhile, Byron Lichtenberg reported successful completion of the wide-field camera checkout, which has been installed in the scientific airlock. Once again, now receiving downlink television.
This is experiment 3201. Did you ever try taking pictures of the twilight in the number 3, that is to say 5896 filter? That's a sodium line. That would be interesting.
Yeah, I'll use that filter first. I have taken pictures. I don't remember how close they were to sunrise.
Okay, I read it.
Continuing to receive live downlink video of the Earth from orbit. Orbiter now passing north over Canada. Now visible from the onboard cameras, the Hudson Bay area, as we continue to receive a live downlink from the payload bay mounted orbiter cameras. Orbiter now passing off the coast of Canada into the Atlantic Ocean, continuing to receive live downlink television.
Space Lab Marshal Ops for Byron. Yeah, we're getting some really spectacular video downlink from the payload bay cameras. You guys are just passed over Hudson Bay, we believe, and I guess we're seeing a lot of cloud patterns over Hudson Bay. Just before that, we're seeing large bodies of water.
Roger, we copy the same thing. I've got it on some of my home movie 16mm film also. Looks like there's some interesting swirl cloud patterns be coming up here in about another 2 minutes or so. I'll be off on the...
We're looking at them too.
port side.
It's sort of a rosette swirl pattern, and you guys should be coming out over the Atlantic right now.
Sure.
And on that 19 operation, we're still checking with them. Because of the changes in the ECAS configuration, they may have some little modifications they want to talk to you about when it comes time to run that 19 operation.
Okay, well, we'll be standing by. Happy to do anything we can.
Okay, thank you, Byron.
And Mike, just one question for the 33 people. We noticed that Bob put the old magazine back in. Did he ever run the ECAS and reset the frame remaining counter over?
I don't believe that ECAS has run, nor has the frames remaining counter been reset. I think that we put the first magazine back on. That was requested just to keep the camera interior clean. In fact, Wubo and the 33 team are discussing some workarounds.
Okay, real good. Well, already filmed. If there is any film left in there, be happy to reset the film frame counter on the ECAS for him sometime.
Okay. One of the guys told me he believes there's about 20 frames remaining on that big magazine. I don't have the exact number, though. We'll be back with you on that. Yeah, I got another confirmation that there are approximately 20 frames remaining.
Okay. Well, we'll stand by.
They may be real precious if we're unable to get that second magazine working, so we're not going to take any pictures for a while here until we understand the problem a little bit better.
Okay. We're going sort of into nighttime now.
And that concludes this portion.
Space Lab, be advised, we lost our TV, which was expected, and thanks a lot for the good show.
It was Brewster that did it.
Roger, thank you, Columbia.
And we're now receiving pre-recorded television being dumped off of one of the Space Lab video recorders. This is television that was recorded off of the AEPI camera, the Experiment 3 payload bay mounted camera. It's primarily data television.
Partial ops, Space Lab.
Go ahead.
Well, the procedures for extending 22 wait until it gets dark. It is twilight up here for quite a while, as you know, and the light is very dim, no more than room light. I wonder if the procedures people wouldn't want to think of allowing 22 hatch opening and table extension once we get in about 5 minutes or so of nighttime and pick up a little extra time that way. Over.
Okay, and we're looking at that right now and talking with the 22 PI. Stand by.
An MSDR message. Let me look and see. See anything? It was an old UHV one. And, Marshal Ops, do you guys copy? We have an MSDR alert bit, but I didn't see anything up on the CCO that showed either a stop or a fault.
Okay, we copy, got that MSDR alert bit. I'll check with the 300 team, see if they're getting data now, and give you some advice where that might have come from. Are there no flashing lights on the CCO?
Yeah, there are flashing lights. The UHV has been flashing for quite a while.
Okay, I understand. Thank you.
Houston, Columbia, air to ground 1.
Space Lab, this is Houston on air to ground 1.
Houston, this is Columbia calling. Are you going to use camera D during this nighttime pass?
Stand by, Brewster. Sounds like your SIMO. Big echo.
Harry, did you have any traffic for Space Lab?
We're answering your call on air to ground 1. No traffic for Space Lab.
Okay, that was Brewster. Out.
Okay.
Well, how's this? Is that better?
Boy, that's better, Brewster. Go ahead.
Okay, are you going to run camera D this nighttime pass?
Columbia, this is Houston. You've got it for the nighttime. We'll keep the TV until you pass the African coast, and then it's over to you after the nighttime.
Say again, Mary?
Roger, Brewster. We'll keep the TV and work with it until you hit the night delineator. You can have the TV after we pass the African coast.
Okay, fine.
And we're AOS over Madrid. We'll meet you over on UHF. And this is Houston moving from air to ground 1 over to UHF.
Okay, see you there. Swap, Space Lab.
Go ahead, I believe it was Byron.
Bill, quick question. I guess we should have been thinking ahead, but since there's nothing for me to do this nighttime pass, we could have put 22 out and take a picture. We're pointing somewhere for Faust, so maybe it'd be good for 22 also.
Okay, we'll look at that.
Continuing to receive downlink television from the AEPI camera. This is primarily data. It was focused on a star field to gather data on a particular star field. However, the focus of the camera was done early on. It was a little bit out of focus. It should clear up a little later. We do not know if that will be on this particular downlink, however. The investigator, Steve Mende, reports, however, that the data that he's getting from this, which is visible in the encoded numbers at the top and the bottom of the frame, is definitely good data. And we are once again receiving live television from the cargo bay mounted cameras of Columbia. In the field of view is the habitable module in which the scientists are doing their research work.
Space Lab, this is Marshall Operations for Byron.
Mike?
Yeah, I have some clarification on the upcoming run of Experiment 1-9er. As you're aware, we're not running CPAC, and the 19 ops team would like to have you put Experiment 19 into its high geometry factor, that is high sensitivity mode, for both the first run tonight, which is scheduled to be run automatically, and the second run also tonight, the second half of the night, which is scheduled to be run by you. It's a manual run. And how you can do that, to put it into high sensitivity mode, is if at 2 hours and 44 minutes, about a minute from now, if you just call up the 19A display, you can just give it an item 16, and that'll pop it into the high geometry factor condition. The ECAS is already being loaded automatically through STLs.
We've been watching that happen.
Say again, Byron?
Sounds fine. Roger, we understand, Mike, and Wilco.
Real good. Thanks a lot, Byron.
Once again receiving pre-recorded television, this from the Space Experiments with Particle Accelerators black and white monitor television camera out on the pallet.
Thanks, Brewster. And Mike, right now I'm looking at the 19 alpha display, and the geometric factor shows high without doing anything.
Okay, we copy the geometric factors high, Byron.
Toggle it and see if it changes. I just did an item 16, and it doesn't change on the 19 alpha display.
Yeah, we copy.
Now in the field of view, the top of the
Take a quick look at 19G and see what we got here.
top of the habitable module.
Now, Brewster, I would like to know if you're getting some of the tail glow activity.
Now moving across in the field of view is the Experiment 34 microwave dish.
Okay, now we can confirm the geomag factor is high.
This experiment developed to attempt to develop an all-weather microwave remote sensing system situated overlooking the starboard sill of the orbiter. Once again looking at the insulation covering the aft end cone of the Space Lab habitable module. All video recorded earlier on board using the CPAC monitor television camera, a black and white, low light level television camera, part of the space plasma physics investigations being carried out on this mission.
Mike, South County on time.
We copy.
And Marshall, Space Lab for the 19 people, I went ahead and did item 16, but as you probably guessed before, that toggle is from high to low. When I looked up on the 19G display, it was in low, so I toggled back to high. So I think we're sitting at a high geomag factor now.
Okay. Thank you, Byron. Yeah, what they want is the high geometry factor, which gives them high sensitivity.
Now receiving downlink of pre-recorded television from inside the habitable module, the change out of experiments in the scientific airlock, Byron Lichtenberg working with the hatch, and Owen Garriott working with the body restraint system, a portion of the equipment for experiment 201, one of the European life sciences experiments. Lichtenberg stowing the hatch cover behind the last rack on the starboard side of the habitable module. This is the activity that occurred earlier today.
It's all finished, huh?
Removing experiment 20 from the scientific airlock, and
Say again, Byron, I didn't copy that.
I think the automatic 19 operation is all finished there. Went away.
Yeah, what they had scheduled was one automatic run through the STLs, except for that one little change that they asked you to do that you took care of. But there's a second run that's fully manual. You'll have to go to your manual ops cue card and run through that for them, if you don't mind.
I'll be happy to.
Owen Garriott now at the panel from which the scientific airlock is operated, situated at the aft end, toward the aft end of the module, on the shell of the scientific airlock. This is the panel used to read pressures inside the airlock.
Okay, timeline 04, huh? Guys?
And also to crank the airlock table, the experiment table, in and out of the airlock. Table is now being retracted from the airlock with the experiment 20 installed.
And Space Lab, this is Marshall Ops. We're just getting our playback of the outstanding video that you guys took of the SAL experiment change-out activities. You guys did a terrific job in camera setup. We're watching the whole procedure as it went on there, and it looks really terrific. We also got views from both cameras.
Yeah, that's good. Unfortunately, you'll see we forgot to switch it on as we moved the 022 out of the rack, and it'll come back on once we have 22 on the table. That's one of the toughest things to do, is to coordinate the TV ops, switching cameras and things when you're right in the middle of doing an experiment operation like that.
Yeah, I understand. Something as big as the 22 experiment uses both crew time, both crewmen full time. How did that thermal barrier come off? Looks like it was a pretty slick operation and didn't slow you guys down at all.
You mean the cover on the camera?
No, I meant the thermal barrier at the bottom of the SAL table.
That's a piece of cake.
And Space Lab, you have two timeline messages in queue. Just please ignore.
Thanks, Bill. Welcome.
Visible in the field of view, the table extended into the airlock, and near the bottom rim of the airlock is visible the PICPAB, or experiment 20 package. Lichtenberg and Garriott now at the stowage area, preparing to dismount the experiment 20. It's stowed in the double rack right to the port side of the module. And just below that is where the camera, the wide field camera for experiment 20 is situated. Meanwhile, as we continue to receive downlink television on board Space Lab crew conducting space plasma physics experiments, specifically they're operating experiment 19, which is a low electron flux experiment, and also the far ultraviolet telescope, one of the astronomy experiments, is operating at this time.
Marshall Ops, Space Lab.
Go ahead, Byron.
Okay, question for the 19 people. All of, and except for one ring, I don't see really any graphics on my 19G display. I don't see anything at all.
Okay, and we'll look at that. We'll be right back with you.
Might mean the data's off scale low. Just don't know. We'll check in with them.
I show a mag field vector of the azimuth of 144, Coela 28, and I would expect my ring number 4, which has an as of 157, to give me something.
Okay, and the PI is looking at his data on the ground, Byron, and he confirms your observations. And he thinks that just we're in a position that we're just not getting good data.
Bill, do you have an idea if we're going to be over water anytime in the next 5 or 10 minutes?
Stand by. We'll look at the map. Yes, you should be over water here in about 3 minutes, Owen.
You're heading south off the tip of Africa, and you're heading down to fairly southern extreme magnetic latitudes. You'll be over water in another 3 minutes.
That's Ralph Skip 14 message again.
We copy.
And Space Lab, this is Marshall Ops for either Byron or Owen.
Go ahead, Mike, I'll take it.
Yeah, sure. 2 notes on the activities coming up in the next hour. You've probably heard that the CPAC battery charge activity has been deleted. The batteries are fully charged and we have not been using the EBA. And also on the upcoming ballistocardiography experiment, Professor Scano would sure appreciate it if you could find time to fit a run on both yourself and on Owen into that slot.
Sure, we can do it.
Thanks a lot.
And Byron, when you have a chance, do it op on 14.
You got it.
Scratch pad lines are marvelous, Byron. And we copy that too.
And we're continuing to receive pre-recorded downlink video of the stowage of experiment 20 and preparations to unstow experiment 22. The
Looks like time's coming up here for me to shut down experiment 19.
Okay, we copy on the shutdown on 19.
There was a brief period in the middle of that downlink when we switched to live television from forward orbiter bulkhead camera looking aft in an attempt to capture and forward to the transmit to the ground some live video of shuttle glow phenomena around the tail of the orbiter. That glow almost not visible to the naked eye here in the payload control center. Once again, we resumed the pre-recorded video downlink.
Space Lab, this is Marshall Ops for Byron, if you have a moment.
Go ahead, Mike.
Yeah, real good. The first question we had is, the last time that you did a resume on the UHF, was the shorting plug installed or was it removed?
I had removed it prior to doing the resume on the UHV.
Yeah, the 300 team wonders what exactly happened when you did that resume with the shorting plug out. Did it just go steady for a while and then start blinking again, or what?
Affirmative. It went steady for a while, and then I got the UHV stop and the blinking ops again.
Yeah, okay. Anyhow, the 300 people would like you to help with just a little bit of troubleshooting. What we hope to do, if you have a minute, is to modify the detection threshold for the UHV experiment using the open and close buttons, and then do a second run, or in fact even several more as the mission progresses, and help them with their troubleshooting. Can you do that now, or should we delay that till later?
That's a very good time. I'm standing right here. Shoot.
Hey, terrific. The first thing we'd like you to do, stand by 1 second. First thing we'd like you to do is replace that shorting plug into the UHV assembly. And a second thing we need you to do is one of these opens and closes, which I'll read to you as soon as you got that shorting plug installed.
Okay, shorting plug's in. Go ahead.
Great. Go to the CCO and open 102442 and read it back before you enter, please.
Roger. 34010002040402.
Terrific. That's a good read back. Enter that.
Place.
Now verify that on line 8 you read 072027, please.
Set. Confirmed.
Real good. Now I'd like you to enter a close close 112700 and read it back.
I'm sorry, I have to say it again. I started to punch it in before you said it. Go again.
Okay. I need a close 112700.
Okay, I show 410102070000.
Great. That's a good read back. Enter that one.
Okay, and the line 8 went to 2700.
Okay, we're going to go LOS in about 30 seconds, so we're going to continue this procedure next time we get a little time. There are some other opens and closes that we'll need done, but it's no rush on this activity.
And we're just getting the tail end now of the installation of the very wide field camera into the scientific airlock. That was pre-recorded television on board the spacecraft. 5 days, 3 hours, 6 minutes mission elapsed time. We just have had loss of signal with Spacelab through the tracking and data relay satellite. We anticipate...
and Spacelab will see you at Aurora at about 3+21.
Okay, bye-bye.
And we're anticipating reacquisition of signal through Aurora in just over 13 minutes. We'll have a report on the activities of the last pass here shortly. At 5 days, 3 hours, 8 minutes mission elapsed time. This is Marshall Space Lab Operations.
This is Mission Control Houston. The flight deck continues to be a fairly quiet place to be these days. The Capcom, Mary Cleve, and Columbia pilot Brewster Shaw just acknowledging AOS and LOS at most stations. Although during the UHF pass over Botswana, Brewster Shaw did look out the window and our report, he was able to very clearly see the lights of Johannesburg, South Africa, which were very visible in the darkness of that continent as he flew over. Mission elapsed time 5 days, 3 hours, 8 minutes. This is Mission Control Houston.
This is Marshall Space Lab Operations. During the last acquisition of signal, we received a considerable amount of downlink television, both live and pre-recorded. initially, we acquired television of the orbiter cargo bay with Space Lab nestled in the bay, and the Earth in the background as the orbiter and Space Lab passed over the North American continent and out into the Atlantic Ocean. This was followed by some downlink television, pre-recorded television of some AEPI camera work that had been done earlier of a star field to gather a low light level data on that star field. While the star field was not visible in the picture, Principal Investigator Steve Mindy indicated that he was pleased with the data that he was seeing from the numbers that were across the top and the bottom of that image. Additionally, we saw some black and white television from the monitor television camera of the space experiments with particle accelerators, hardware mounted out on the pallet. That included some star field. Additionally, visible in the picture was the limb of the Earth. Received some downlink from inside the module, also pre-recorded, at about 5 days, 0 hours, 30 minutes, give or take a few minutes, of the removal of the Experiment 20 passive package from the airlock and installation of the wide field camera. During a report on that activity earlier, Byron Lichtenberg had indicated a little bit of difficulty in using the torque wrench in the installation process, and visible in that downlink was some recorded video of him working with the torque wrench toward the end of the link. That downlink was interrupted by some live television of the tail of the orbiter. Two purposes. One, an attempt to look at shuttle glow, see if that was visible, and also flight deck had indicated that there was some lights visible in the vicinity of Johannesburg, South Africa. The image, however, here in the Payload Operations Control Center was very poor, and the tail of the orbiter just barely visible in that field of view. On board Space Lab, the crew worked both with a space plasma physics experiment, Experiment 19, a European Space Agency low-energy electron flux experiment mounted out on the pallet, and also a far ultraviolet space telescope, Experiment number 5, sponsored by NASA. 8.5 minutes now to reacquisition through the Aurora Valley ground tracking station. 5 days, 3 hours, 12 minutes mission elapsed time. This is Marshall Space Lab Operations. This is Marshall Space Lab Operations at 5 days, 3 hours, 20 minutes mission elapsed time. Standing by now for reacquisition of signal with Space Lab through the Aurora ground tracking station on orbit number 83. And during this period of time, the crew is scheduled to be preparing to conduct one of the life sciences experiments, Experiment number 28. That's a European Space Agency provided experiment, three-dimensional ballistocardiography and weightlessness. It's designed to record physiological parameters on a test subject as he both exercises and relaxes in the Space Lab.
And Space Lab Marshall Ops through Aurora for about 4 minutes.
Hey, Ridge Rod and Clear, Bill. We just had another Ralph Skip 14 and a MSDR bit, and it's the SIU data fault light on again.
We didn't get the last item, Byron.
Roger, MSDR fault. SIU data light on, data fault on.
Okay, and once again, we want you to re-op RAL 14.
Okay, good work.
And Space Lab, this is Marshall Ops. We'd like to have you cancel that battery charge on CPAC.
Bill, we copy.
And Space Lab, we have you for about another 30 seconds. We'll see you at Hawaii in about 14 minutes at 3 plus 139. And we'll have the PI enabled at that time on experiment 28.
Okay, Bill.
This is Marshall Space Lab operations, 5 days, 3 hours, 26 minutes. Loss of signal with Space Lab through Auroral. Next acquisition scheduled to be Hawaii in approximately 13 and a half minutes. That's scheduled, that acquisition scheduled to occur on orbit number 84. 5 days, 3 hours, 26 minutes. This is Marshall Space Lab operations. This is Marshall Space Lab operations, standing by now for reacquisition
This is
of
Mission
signal.
Control Houston. We're coming up on AOS at Hawaii in a few seconds. Get a voice with Space Lab. And when we acquire Teeterus at Mission Labs time, 5 days, 3 hours, 50 minutes, we'll get some previously unscheduled TV of Earth views.
And Space Lab, Marshall.
I didn't hear you on there. I called you a couple.
10 minutes through Hawaii.
Space Lab, this is XO28.
Stand by, 28. We haven't made contact.
Stand by, please. Marshall Ops, we're right in the middle of doing 28, so...
Roger, we copy.
Hey, Marshall Ops, Space Lab here. Owen's in the middle of doing his exercise now. Anything big?
Space Lab, this is XO28.
Oh, XO28.
We would like to know if the tape runs properly, if the ECG LED is blinking rhythmically, and if you already...
Sorry, please repeat.
What?
Roger, the tape is running properly, and we've got a good ECG recording over.
Okay. Did you already switch to spare batteries?
Negative, we have not switched to spare battery. The battery level light is off, and there's about 1/5 of the tape left.
Okay.
And we have you for 10 seconds, and we'll see you in 4 minutes through S-band.
Okay. The heart rate is more than 100.
We've lost him. Stand by. We'll have him back in about 5 minutes on S-band, and you can have some more time then. Experiment 28.
This is Marshall Space Lab operations, 5 days, 3 hours, 49 minutes mission elapsed time. Standing by now about 30 seconds from reacquisition of signal through the tracking and data relay satellite. When we reacquire signal, we're anticipating that crew will be finishing operations with Experiment 28, and the Experiment 28 research team here in the science monitoring area will be enabled to speak with the crew. We're also anticipating that the crew will begin its first operation of Experiment 22, the wide field camera. Standing by now for reacquisition as the orbiter approaches the apex of its 84th orbit. And during the early part of this pass, we may receive a few minutes of live downlink television.
Space Lab, Marshall Ops, 40 minutes. And the 28...
We just finished 28 on both. We finished 28 now with both subjects, MS and PS, and the experiment is being stowed away.
Okay, and we have the 28 PI standing by.
Loud and clear, XO28.
Okay. Could you keep the subject still while floating? Could you
The experiment went exactly as nominal, very nominal on both subjects.
So they were kept still. They were not floating free.
You are not readable, but I'm sorry, but you are not readable, but I repeat, the experiment went nominally.
Okay. Okay, over. Thank you.
And for the 28 PI, we can report that we have about, I guess, 15 to 20 minutes of cassette tape left on this first tape, and I don't think the tape has been changed yet, so I think still plenty of tape left. We on the blue shift did not change it.
Okay, yes. Space Lab, XO28. Did you perform both PS and MS on this performance?
Affirmative, we did both subjects, the entire protocol, over.
Copy, thank you.
And for your log sheets, we did the payload specialist was the first subject, and the mission specialist was the second subject.
Copy, thank you.
Voice of Dr. Felice Strollo, representative for Experiment 28, Science Monitoring Area here in Houston.
Was that your timeline, Bravo, or is that the S1 Charlie timeline there? Marshal Ops, Space Lab.
We're copying, Byron.
Hey, Bill, timeline 0 Bravo, you guys have a handle on that, over?
Roger, and we're looking at that.
Yeah, Byron, we've alerted Mum to that, and he's scratching his beard right now, so I guess we'll get some action on whatever's needed there. If you guys have a couple minutes, I can describe our video flow for the upcoming dome run using TV-17.
Hey, well, stand by a sec, Mike. We have a quick question on VTR number 2 shows 57 minutes remaining. Did you guys dump that, or did you just rewind it for us so we could change it over?
Okay, and
stand by.
DMC is looking at that.
I don't think it's been used, has it?
I see. Byron, the DMC tells me that on VITR number 2, there should be 57 minutes on it, and it should be a fresh tape. He believes that that is a fresh tape ready for you guys to use on the upcoming dome run.
Very good. We think the same thing, thank you. So we don't need that tape removal at 4 o'clock then.
Yeah, on VITR number 1, it should be about half full, and you will not need to change that out.
Roger, the PCAP showed a recorder 2 change, and we just confirmed that we do not need to change it. That's good news.
Yeah, that's right. You do not need to change it. It is good news. By the way, we're running a little bit ahead. That is, we're a little bit fat on available tape. If you guys use only about half of this tape on number 2, we might be able to fit in some additional data collection a little later on, perhaps when we get into the material science work.
Roger, that sounds good. Only needs 24 minutes for the dome.
That's right. I figure all you need is about 24 minutes for the dome. And right now your allotment is to use the whole thing for the dome. Be silly to waste it, but who knows, we might find another good use for some additional data to go on that tape.
And Marshall, Space Lab, we saw the new uplink attitudes for these maneuvers. They came up this morning. We're very expectant that we're going to have the right attitude, over.
Yeah, there have been a number of changes in the attitude timeline. Let's hope that this whole replanning system works. They're coming up now, of course, on a 22 attitude.
Did the 22 and others reach any conclusion about about the early deployment of the table out of the cell, over.
On
twilight here, 5 minutes or so.
Yes. The word that we have is that, yes, you are a go for deployment a few minutes early, but we do want to stick reasonably close to the nominal timeline. We understand that you're getting long-duration twilights up there, and you should feel free to make use of that. They just don't want to violate by more than a few minutes the nominal cranking in and cranking out timeline.
Good. I'll hold it to about 5 minutes or so prior to sunset.
We copied. Thank you, Owen.
And Space Lab, we do have the 21 PI enabled Graham Bittis. Correction, 22.
Here in the Payload Control Center, Graham Bittis, European Space Agency engineer, representing Experiment 22, standing by to talk with the crew as soon as this momentary dropout in communications, as soon as we regain communications following this momentary dropout.
And Space Lab, we have Locke again, and Graham Bittis is on the line.
Space Lab ESA 22. I understand. Space Lab ESA 22. Space Lab ESA 22. Copy.
Here we go, Brewster. We're about to unlock the outer hatch. Comes, Brewster.
Okay, Space Lab, this is Marshal Ops. We just got indication that your outer hatch is fully open.
Marshal, Space Lab.
Real good there, Space Lab. This is Marshal Ops. Copy you loud and clear, Byron.
Brewster, do you see where the horizon is? Okay. Okay, thank you. I understand. Brewster, I guess we're out of contact, huh? Could have voice. Yeah, I can see it now, just when it got darker. Thank you.
Space Lab ESA 22. Space Lab, this is ESA 22. How do you read me? Space Lab, this is ESA 22. How do you read me? Space Lab, ESA 22. How do you read me?
Roger, ESA 22. Read you loud and clear, over.
Owen, we'd like to make an extra exposure in this run, but we're a bit uncertain of the timing. What we'd like you to do is to run the following sequence of commands. We'd like you to do when the timeline sequence is finished, we'd like you to do an item 52 to set the ECAS into step mode. Then do an item 51. The effect of this is to switch the HV on again. Then to set item 4 to 2. Then to set item 5 to whatever time is remaining till sunrise, less 60 seconds. And then an item 6. How do you copy me?
We copy all of that loud and clear.
Thank you, Spacelab.
And Graham, be advised, it looks like we'll probably have, I would say a good 6 or 7 minutes. So that'll be, around 300-400 seconds or so.
That's what we think as well.
Now, be advised, everything seems to be operating just perfectly. Are you getting any data on the ground?
Yes, we're seeing it nice and clearly. We've got about 127 seconds on the current exposure.
Roger, and things look really good.
They do indeed. Thank you.
Space Lab, this is Marshal Operations for Owen, if he's...
Hey, Owen is tied up in this hood right now. Go ahead, Mike.
Okay, Byron, we had another couple steps in the work we're having you do on the UHF, and if someone could carry those out, that'd be great. And we also have a message concerning a 300 power supply common equipment workaround that I'd like to voice up. And finally, I have some good news about the experiment 327. It's a go to let you start that early, and a little change in schedule on that 327 ups coming on later on today.
Mike, we're both kind of busy right now. If those can wait, because obviously Byron's in the middle of that experiment, and I've got my head in the hood back here. Can I?
It's not a rush item.
Hey, Mike, you can go ahead. I'm here right by the middle of the DDU, so I can keep an eye on 22 and do your steps on the MSDR if you want.
Oh, that'd be terrific, Byron, provided you don't glitch 22, and as long as Graham Bidis is keeping his eye on its performance, perhaps you could go on to our second step here. You've already done for me one open and one close, and I have another open and another close for you. And let me just read you out those keystrokes. I need now an open 102444.
I am showing 34010002. 040404.
That's a good readback. You can enter that one.
Okay, all balls in a 3.
Real good. And now I need a close 000070.
Showing 44000000000700.
Good readback. You can enter that one.
It changes to 4 balls, 70.
Terrific. Now I wonder, is the UHV ops lamp flashing?
Affirmative.
Great. You may now UH.
Steady ops light.
Terrific. This sequence of tests that we're running, in a few minutes I'm asking you again to repeat this open and close, the ones I just read you, but I'll read them to you again with successively smaller numbers. This time you keyed in a close 70, and next time we're going to do it with a close 60 and a 50. What we're doing is changing the threshold of the UHV wave detector, the device that a coefficient of restitution of the sample UHV chamber. And we appreciate your call on that.
Hey, Roger.
We have a second item from the 300 ops team. As you know, we've had some trouble with the electrical power that supplies energy to the MHF and the IHF. And if you have some time, I'd like to read you a procedure involving a panel removal and some connectors disconnecting. But I don't want to interfere with your 22 experiment ops. So whenever you're ready to copy, give me a shout and I'll read that up.
Hey, let's see. Wait about a couple of minutes for that, then we're 2 to 3 minutes away from the end of the very wide field camera. How long do you think it is?
It's about 2 or 3 minutes.
Well, why don't you go ahead and start, and I may interrupt you here, but I guess go ahead and start.
Okay, terrific, Byron. I believe Graham's also getting good data, so he's also keeping his eye on the displays. What we're going to do is, first step is to switch the MHF-IHF heater switch to off, Oscar Foxtrot Foxtrot. Second step we'll want you to do is to remove the front panel, which is below the MSDR power supply. That is to say, it's right above the EPSP. And you'll find it needs 6 screws pulled in order to do that. Your third step is to reach down inside where that panel is and to disconnect 2 cables. One is called J5 and the other is called J7.
Got that?
Okay. The fourth step is then to go to the panel and switch the MHF-IHF heater to the on position. The next step is to open 174362. Enter. The next step is to close 077760. Enter. And the next step is to data 056176. Enter. And tell us what you see on line 5 of your display.
I've got all that. Let me read out the open and closes.
Yes, please.
174362.
Correct.
Close 077760.
Correct.
Hey, got it.
Okay, that data number I gave you should display the voltage coming out of the electrical power converter, and it'll tell us if we're getting any electrical power or not. Finally, after you've examined the display, line 5, we have 2 other instructions. One is to open 174362, enter, and close 000000, enter.
Those last opens were 174362 and a close 6 balls.
Exactly right. Thank you very much, Brian. This can be done at any time. AOS would be nice, but is not essential.
Okay, Roger, and last of the programmed exposures now for the very wide field camera.
Byron, I missed your last transmission. Could you say again?
Roger, I just said that we're on our last exposure, last programmed exposure of the very wide field camera.
Real good. Understand. Thank you.
Space Lab ESA 22.
Roger, go ahead, ESA 22.
Can I speak to Byron?
Got him, go ahead, Graham.
Okay, Byron, can we go ahead with that exposure sequence that I gave the commands to Owen just now?
Absolutely.
Would you like me to repeat the sequence of instructions?
Negative, just follow along, see if I do it okay.
Okay, a copy.
I'm showing about 9.5 minutes left, so let's make it 8.5 minutes, which is 510 seconds.
480 seconds.
Sound good, 480?
480.
Yes, you got it.
Copy.
Okay, and it's in work, Graham.
Okay.
Okay.
Graham Bittis here in the Payload Control Center, working with Byron Lichtenberg on the operations of the very wide field camera.
It looks good, Byron.
Hey, Roger. Marshal Ops, Space Lab. Marshal Operations, Space Lab.
Go ahead, Byron.
Hey, Bill, I guess really for Michael, the MSDR people,
Go ahead, Byron.
MSDR crew alerts it. Yeah, what kind of a tool do I use to get these bolts off here?
Byron, those 6 panel screws are going to need this very same tool that Ulf used when he removed a little semicircular plate around a wire, the thermocouple cable, on the IHF front panel. And I don't know which tool that is, and Ulf's asleep. But you'll have to study that panel and then discover what it is for those 6 screws.
He didn't use this tool to get those off. All he did was pull off the 4 regular screws and then just pull the wire out through the panel.
I see.
Check it out.
If you'll take a look at that panel, you can probably tell what sort of fasteners holds it down.
Looks like a cheese head type. So we got the UHV stop, Michael, 505 again.
Yeah, okay, I'll just have to let it sit there. We're going to try and keep you in contact with Experiment 22 and then turn you guys and the air-to-ground over to Experiment 102, who also has a number of things he'd like to talk to you about before you get this dome run rolling. We also have one other remark for you. As soon as you're done with the dome run and have things stowed, you go for 327 Bravo operations. And you shouldn't let 327 Bravo run past 7 hours because we have some additional work we'll be in touch with you about concerning the CPAC experiment. That is, 327 is brought earlier in the schedule than is shown on your PCAP.
Stand by.
Space Lab ESA 22.
Byron.
Byron, when the exposure comes to an end, can I suggest that we continue nominal operations by removing the ECAS and then bringing the camera back into the cell and closing the outer hatch?
You just want to do the remove an ECAS, right?
When the exposure is finished, yeah. That'll put the instrument into a safe state.
5 seconds.
Okay.
I guess Marshal Ops, you guys saw that depth 05 message?
Roger. We see it, and we also see the Rouse skip.
That one. And Graham, the pressure looks like it's holding nicely in the film chamber, Experiment 22.
Okay, we copy that.
Yeah, Marshal, we got another MSDR fault bit, but there's nothing set up on the panel at all. Exposure's finished for 22.
Data here on the ground indicating that the very wide field camera is being retracted now into the scientific airlock following its first series of operations on orbit after being installed in the airlock earlier today. That camera looking at faint ultraviolet emissions in the celestial sphere. About 2.5 minutes remaining in this acquisition of signal through TDRS, and we anticipate, if time permits, once that camera is totally retracted, Larry Young from MIT will be discussing an upcoming run of his experiment with Byron Lichtenberg.
Okay, and we're just closing the hat, bringing stuff in.
Space Lab for Byron, this is 102.
Larry, howdy.
Byron, your co-investigators down here are sharing their observations with excellent data flowing to us in the Life Sciences Science Monitoring Area at Houston. Please thank Owen and the others for me.
Okay, will do. We copy. Yeah, we copy.
Yes, Byron, we have only a minute. I'm going to read you 3 instructions and no acknowledgement is required. On the next run, we find the preliminary results of the in-flight dome runs with bungee cords very exciting. Please take pains to continue to report the quality of action, in particular with the bungee cords attached, I would like each of you to describe whether you are experiencing complete constant roll rate, even if it's not saturated, or limited visually induced tilt. Do you copy? Space Lab Byron in the blind. Next, after completing the first dome run, if you feel up to it, you might start dome run 2 again at the end and observe the rotating pattern without using the bite board. Please report the sensation while making gentle head movements successively in pitch, yaw, and roll, and compare it to the sensations observed in the PCTC, which you and Owen discussed with me 2 weeks ago at Dryden.
Copy.
Finally, if time permits, you may run the option runs during LOS. I am assuming that you are doing this run in the same order as the last one, single screen view of the eye, left eye, and you will be using the contact lens. That is the end of my messages. Do you have any comments?
Hey, no comments, Larry. We've got it all, and we'll take a look at it.
See you at 5 plus 23, guys.
This is Marshall Space Lab operations at 5 days, 4 hours, 41 minutes mission elapsed time. Loss of signal through the tracking and data relay satellite. Anticipating reacquisition through that satellite in approximately 42 minutes, just under 42 minutes. Meanwhile, the next pass is an orbiter mission control only. Anticipated some downlink television, which we did not receive. That was a bit iffy because of the short nature of the opportunity for that downlink television. Additionally, during that pass, the crew on board operated Experiment 22, the very wide field camera. Graham Bittis, European Space Agency engineer who has been working with that experiment, spoke directly with the crew and worked with them as they conducted this, the first operation of the mission, or during the mission. That camera was just installed earlier today into the scientific airlock. Additionally, during that period of time, Mike Lampton, alternate payload specialist here in the front room of the Payload Control Center, provided some troubleshooting procedures to Byron Lichtenberg on the material science double-rack power supply that experienced a short earlier and made it necessary to shut down the mirror heating facility and the isothermal heating facility, both of which were dependent upon that power supply for their operations. That troubleshooting procedure designed to attempt to find a workaround to bring at least one of those two facilities back online prior to the end of the mission. And finally, just prior to losing communications with Space Lab, Dr. Larry Young in the science monitoring area, which is here at the Johnson Space Center, however not co-located with the Payload Operations Control Center, spoke with Byron Lichtenberg about an upcoming operation of one of his experiments, that experiment being the rotating dome. During the next TDRS acquisition of signal, we're anticipating some live and also some pre-recorded television. That television scheduled to start about 5 hours, 5 days, 5 hours, 23 minutes, and scheduled to include some orbiter television as well as some television of some additional television of the scientific airlock operations, and that television downlink scheduled to end with some live science data television of the rotating dome experiment. At 5 days, 4 hours, 44 minutes mission elapsed time. This is Marshall Space Lab Operations.
This is Mission Control, Houston. Events remain fairly quiet on board the flight deck in Columbia. Capcom, Anna Fisher, and Brewster Shaw principally just acknowledging AOS and LOS over the UHF stations at Ascension Island and Dakar during that most recent pass. As a note to news media, the White House has released to the press President Ronald Reagan's schedule for Monday, December 5th, which shows the president participating in a satellite teleconference with West German Chancellor Helmut Kohl and with a Space Lab crew beginning at 8:40 a.m. Central Standard Time. This has been a fairly busy period on board Columbia for Brewster Shaw. There have been in the past 2 orbits, 6 maneuvers in support of laboratory experiments, and those of course involve extensive keystrokes and commands to the digital autopilot on board the ship. We're reconfiguring the air-to-ground mission audio to encompass the Yargati Pass coming up in 4 minutes. Yargati is UHF only, so it will be exclusively an opportunity for air-to-ground between the Columbia Flight Deck and Mission Control Center here, so we'll make that available on this next pass. And to repeat that earlier advisory, the White House has released to the press President Ronald Reagan's schedule for Monday, December 5th, which shows the president participating in a satellite teleconference with West German Chancellor Helmut Kohl and with the Space Lab crew beginning at 8:40 a.m. Central Standard Time. AOS through Yargati expected in 3.5 minutes at mission elapsed time 5 days, 4 hours, 46 minutes. This is Mission Control, Houston.
Columbia, Houston, coming to you and the folks in back through the outback for 4.5 minutes.
How about that?
And Columbia, Houston, you may be hearing some noise on this pass because there are a lot of thunderstorms in the area.
Okay, well, it sounds fine so far, Anna.
Columbia, Houston, are you aware of the VTR that John took yesterday over the African, one of his passes over Africa?
Sure am. I watched him do it.
Yeah, Brewster, we're interested in playing that back sometime over the next Tidris Pass after you get into the nighttime portion of the Tidris Pass.
Gee, I ought to ask John. He's sleeping.
Okay, we'll get back to you on that. Columbia, Houston, we'll get back to John on that question. It was just quiet down here, and we wanted to look at some pretty video.
Okay, I'll see if I can find it.
Columbia, Houston, we're about 30 seconds LOS. We'll see you again through Bermuda at 5+34.
Okay, Anna, see you there.
See you there, Brewster.
This is Mission Control Houston. We've lost communications capability through the UHF station at Yargity. Air-to-ground will be through the TDRS system. With the Space Lab crew, we'll configure mission audio to facilitate broadcast of those transmissions, and that will occur with acquisition of signal in 28 minutes. Next orbiter air-to-ground opportunity will be through Bermuda in about 40 minutes, so it's a long LOS period for us. And while the opportunity presents itself, I'll repeat the earlier statement advising that the White House has released to the press President Ronald Reagan's schedule for Monday, December 5th. Shows the President participating in a satellite teleconference with the West German Chancellor Helmut Kohl and with the Space Lab crew beginning at 8:40 a.m. Central Standard Time. Mission elapsed time is now 5 days, 4 hours, 55 minutes. This is Mission Control Houston. This is Mission Control Houston. The following release has just been issued by the NASA News Center in Houston. NASA and ESA managers have decided to extend the STS-9 mission by 1 day, contingent on satisfactory weather conditions for landing at Edwards, California. The decision was made when it became clear that reserves of critical orbiter supplies, including fuel cell reactants and propellants, will easily support an extension, and after a review of Space Lab science objectives showed that extending the mission from 9 days to 10 could add substantially to the mission's science return. The extension of the mission offers a unique opportunity to all of the science disciplines involved in Space Lab. Weather will be a key factor in finally committing to a one-day extension because of a strong desire to assure planned and backup landing opportunities at Edwards, where facilities are in place to handle post-landing life science objectives. Mission managers will continue to review the status of crew, orbiter, Space Lab, and weather on a daily basis in determining whether to continue the mission up to and beyond its 9 days duration. If the mission is extended to 10 days, landing will occur at 1:10 a.m. time, Thursday, December 8th. Copies of the release will be available in NASA news centers. And the earlier release that we mentioned, let me repeat that as well. The White House has released to the press that Ronald Reagan's schedule for Monday, December 5th shows the President participating in a satellite teleconference with West German Chancellor Helmut Kohl and with the Space Lab crew beginning at 8:40 a.m. Central Standard Time. AOS due through TDRS with Space Lab in 6.5 minutes. Mission elapsed time presently 5 days, 5 hours, 16 minutes. This is Mission Control Houston. This is Mission Control Houston. To repeat the last part of that, just to make sure I said it correctly, if the mission is extended to 10 days, landing would occur at 10:01 a.m. Central Time on Thursday, December 8th.
This is Marshall Space Lab operations at 5 days, 5 hours, 21 minutes mission elapsed time. Standing by now for reacquisition of signal through the tracking and data relay satellite system, both S-band voice communications and high-rate data through K-band, in approximately 1 minute. During this acquisition of signal, the crew is scheduled to be continuing with Experiment 102, the rotating dome operations, and following that, the crew is scheduled to begin another series of operations with Experiment 22, the wide field camera. We are anticipating that we may receive some downlink television also during this acquisition of signal. Standing by now for reacquisition, just under half a minute.
And Space Lab Marshall Ops through TDRS, we've got you for about another 41 minutes, and hopefully we're going to have some live TV of you inside the module.
just finished the dome runs, and Byron is just doing the last part of his with out the bite board, and I'm calling up 22 at this time.
Okay, Owen, we copy, and before you start the 327 operation at 5 plus 40, we'd like to have Mike Haynes come on the line and talk to you before that startup begins.
And Space Lab, we want to know if you'll let us downlink some real-time video from the T-17. Would that be all right?
Try with us.
Okay, great. We'll configure that. Thanks a lot. We'd like to see Byron's eye.
Anticipating some downlink video from the Space Lab.
Anymore. We're in the last optional runs when I'm out of the bite board, but I can go back in for a little bit. Camera 2 is in the dome. Camera 1, you've got a... Camera number 1, you've got some sort of wide angle shot, but it's not position super, but you might be able to get something over. We've got the 102 PI on the line. We can make some online observations.
Yes, Byron, this is 102. Go ahead.
Larry, the runs went as normal. In my case, the same feelings of less compelling vection than the airplane, about the same as on the ground. This run, I've got my head out of the bite board, and when I make head roll movements out of the bite board, I get a much stronger sense of complete rotation of me in the Space Lab, even with the bungees on.
Copy that. I'd go on.
Okay, it's about, I'd say, 80% saturated, and that's even with the bungees on. But it needs a little bit of head motion to really pick it up.
I understand. Do you believe the head movements are beginning to start the vection, are you, Byron?
The fact that your head is a little loose increases the sensation of vection just the way it does on the ground.
Very good. Did you try pitching and yawing head movements as well?
That's affirmative. The only one that really seems to matter is roll.
Affirmative roll. Did Owen have the same reaction?
Affirm, I think so.
Can you comment on the effect of the bungee cords on whether you got steady tilt, paradoxical roll, or full roll vection?
In my case, it was still full roll vection, but less than saturated and less than the free floating case over.
Any observations of the onset latency?
It's hard to tell. It's almost the same as on the ground. It's within a few seconds.
How about, was there anything provocative about head movements in the dome?
Well, we feel it's a little disorienting, and it's similar to the ground, I guess, at least as Owen described it.
Okay. Does Owen copy what you're saying, and does he have any different sensations that he'd like to report?
I'll give you a few comments a little later if you don't mind, Larry. I'd like to go ahead and get 22 set up and then come back with you, if that's all right.
That's fine, Owen. We'll get back to you later. Byron, can you describe a little bit further what the effect of the bungees is in limiting the sensation of tilt? We're really very excited about that result.
There is no problem with tilt. Like I said, it's a complete roll still. It just feels like you and the spacecraft are rolling together. It is not paradoxical vection at all. It's true vection. All it does, I think, is, in my case, it cuts down a little bit on the sense of the vection, and it might cause a few more dropouts.
Copy that. Byron, I have some questions following up on what we discussed last pass about adjustment of the harness during hop and drop. Once again, could you let us know whether for you and Owen the harness had been adjusted to the marks on your first day and on your second day? Both the vertical chest mark and the horizontal belt mark. Go.
Yeah, I don't think they were. Mine were looser. I was unable really to stand up with them as tight as we had marked them on the ground. And there seemed to be some distension in the stomach area, so I really, a lot of gas and whatever, so that I wasn't able to get the belt as tight as we had it on the ground. I'm not sure about Owen.
And Spacelab, be advised that we are now getting real-time video downlink from the pallet, and we hope to be able to see the SAL come cranking out when Owen gets 22 underway.
Spacelab Byron, be advised that Doug Watt would like you to adjust the harness to the marks on the next hop and drop, if at all possible. It's essential in order for him to be able to calibrate the acceleration associated with the bungee cords.
Do the best we can, but that's what we have the ARU on there for, is the accelerometer, right?
We feel that we need the, if at all possible, that the harness adjustment should be made. Do you have any other comments concerning the quality of the vection on this run? We'll be looking at the data in a few minutes.
No, it's still the same. Getting TV at the eyeball now. I'll put my head back in.
Okay, and while you're doing that, Byron, be advised that this run is taking you over Montreal, McGill University, and MIT. And if you were able to look out, you might check to see if the new snow in your driveway in Wellesley created a problem. Byron, we would like you to make some notes at some point about the stomach tenderness that you mentioned to us.
And Spacelab, we can see Owen extending the SAL.
Actually, what we're seeing is the outer hatch come cranking open, not the SAL table extended yet.
We might have guessed that, since my hand's on the handle.
And Byron, we need you to give us another RAL 21 OP.
I'll be right there.
Now receiving downlink television of the exterior of the Spacelab module. Meanwhile, inside, Owen Garriott in the process
of... Spacelab, we can see experiment 22 come cranking out of Spacelab. Really good real-time shot.
Get any TV of the module?
Extending out of the scientific airlock, a very wide field camera being extended for its second operation of the mission. This camera...
And Owen, that's a beautiful picture of that SAL from out from the rear.
Looks real good, too, Bill, and the movement on the SAL equipment all seems real nice and smooth. It is a little bit hard to rotate both the latch handle and the opening outer hatch handle, but aside from the fact that they require quite a bit of torque, it's nice and smooth and seems to operate very smoothly.
We copy that, Owen, and it's just beautiful.
Yeah, that's nice to hear, Owen. Thanks for the report on that. And Owen, you got a great big thank you from the TV ops people.
Okay. Now, Mike, were you guys able to get any shots of the inside of the module?
Negative, Byron. We've been having a little bit of trouble doing any commanding from the ground. And Byron, we do have the 327 Mike Haynes PI enabled, and your go for start on his procedure.
Spacelab to Byron, this is Mike Haynes. How do you read me? Over.
Mike, read you loud and clear.
Okay, Byron, we've done a little rethinking on experiment 327, and we hope to avoid some of the difficulties which we've experienced with the anti-spread barrier. I've got quite a lengthy table to read over to you, so it will be helpful if you could find a notepad.
Okay, give me about 2 minutes, and I'll be ready to copy.
Okay.
And in the meantime, I'll give a comment to 102 PI relative to that last 102 run point. The floating rotating dome, today I was able to imagine myself rotating a little bit more readily than I was yesterday. It seemed like I could imagine a little bit easier self-rotation. With the bungees attached, it was just about the same. Essentially 40% saturation in each case, however, but of course no physical self-rotation. You felt like you were really established on the ground. Without the bite board, I would say it's the same kind of disorienting effect that you see on the ground. It's you feel all the gyros tumble whenever you find yourself with your head moving around freely.
Copy. That's very complete, Owen. Any further description that you would like to put into the tape recorder, we'd like. This business of the effect of the bungees is just fascinating.
Okay, I'll put anything else on the tape. Thank you, Larry.
Voice of Larry Young, 102 investigator. Debriefing on the rotating dome experiment just completed.
Space Lab for Owen, this is 102. Did you overhear my questions to Byron about the adjustment of the bungee cords during the hop and drop experiment on the first 2 days?
Only the first part of that, Larry, so I can't really give you an answer on that.
Owen, Doug Watt needs to know whether the bungees were adjusted to, the harness was adjusted to the mark for both the vertical chest strap and the horizontal belt strap on days 0 and 1.
I don't remember checking whether the marks were right at the strap or what, or the how it was adjusted. It felt normally, but I don't remember checking it exactly.
Acknowledge, check it on the last run.
Now receiving pre-recorded video of Earth views from the orbiter.
Houston, Columbia, air to ground 1.
Columbia, Houston, on air to ground 1.
And verify for me, please, that flashing water now, we're not in...
Columbia, Houston, say again your last transmission. We broke lock there.
Roger, Anna. Verify for me, please, that flashing water now will not interfere with this nighttime pass experiment ops.
That's in work, Brewster.
Okay, and I'll just hold off on the high temp until we find out for sure.
That's firm, Brewster. We're checking now.
Thank you. The Marshall Ops Space Lab here, the PS.
Okay, Byron, Mike Haynes, do you have your notepad ready?
You go ahead, Mike.
Okay, we tried to tag this information up to you, but the machinery didn't work, so I'm going to ask you to reproduce in your note what I have here in Houston in front of me. There are 5 columns in the table, and the headings on the columns are line reference.
Mike, I'm sorry, I didn't copy that. Could you please repeat?
I repeat, the first column is headed line reference. This is simply a reference number so that we know which line we're talking about later on.
Go ahead.
Next column, front plate position.
Columbia, Houston, on air to ground 1.
Oh.
Yeah, Brewster, you go ahead and put the rad out temp to high. That had previously been coordinated with the payload folks.
Okay, fine. Thank you much. And are you getting the downlink?
That's a firm, Brewster. It's really beautiful.
Okay, great.
And I'm giving air to ground 1 back to Marshall Ops.
Okay, Byron, column 3, reservoir position.
Go ahead, Mike. Just keep reading. Starting at 22, second exposure. Looks like it's counting down 5.
Column 4 is front plate speed, and column 5 is reservoir speed. Okay, Byron, I'm going to give you some numbers to fill in those 5 columns. The first line is Alpha 1, FP position 5.0, reservoir position 5.0, FP speed decimal 9 and 9 and 9, reservoir speed decimal 9 and 9 and 9.
Repeat the line number, please.
Line number Alpha 1.
Let go.
Alpha 2, 17 decimal 5, 16 decimal 3, decimal 111, decimal 100.
Is that a front plate position of 17 decimal 9er?
Negative. Front plate position 17 decimal 5.
Got it.
Alpha 3, 12 decimal 5, 11 decimal 3, decimal 300, decimal 300.
Go ahead, I'm ready for the next one.
Okay, Alpha 4, 36 decimal 0, 29 decimal 9, decimal 126, decimal 100.
Yeah, please repeat the reservoir position, please.
Repeat reservoir position 29 decimal 9.
Copy 29er decimal 9er.
Correct. Let me interpolate a word of explanation at this point. This is the formation of a drop with the plates initially 5 millimeters apart. In line Alpha 2, you form the drop. In line Alpha 3, you advance to contact. And in line Alpha 4, which is a new procedure, you're forming a larger zone, which we were unable to form from the original captive drop because of the anti-spread problem. Clear?
Hey, keep going.
Okay, Brian. Next line, Bravo 1, 5 decimal 0, 5 decimal 0, decimal 9 and 9 and 9, decimal 9 and 9 and 9. Line Bravo 2, 1 2 decimal 5, 1 1 decimal 9, decimal 1 0 9, decimal 1 0 0. Line Bravo 3, 7 decimal 5, 6 decimal 9, decimal 3 0 0, decimal 3 0 0. Line Bravo 4, 3 2 decimal 0, 2 7 decimal 1, decimal 1 2 1, decimal 1 0 0. That completes drop Bravo. Drop Charlie has 5 lines. Charlie 1, 5 decimal 0, 5 decimal 0, decimal 9 and 9 and 9, decimal 9 and 9 and 9.
Flight position 2.5.
Affirmative.
Got it.
Line Charlie 3, 1 7 5, 1 5 decimal 7, decimal 3 0 0, 0. Four, 8, 2, decimal 1 2 4, decimal 1 0 0. Final line coming up. Charlie 5, 3 0 decimal 0, 2 5 decimal 7, decimal 1 3 3, decimal 1 0 0.
Got it.
Okay, Byron, just a few procedural notes as well. The first one, camera B, brief mode, interval 1 second, frames at 9er, 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 other camera settings unchanged.
Got it.
And as in the old procedure, you should be prepared to go over to cine mode at 16.16 frames per second whenever a rapid process is observed, like zone braking, for example, or initial spreading.
Do you understand cine when we have a rapid process occurring?
Correct. Second point, I'd ask you, if you would, to maintain 5 RPM ISO rotation throughout in order that we may check the axial symmetry of the drop at all stages.
Copy, 5 RPM ISO rotation throughout.
Correct. And the final point, we would ask you never to withdraw liquid back into the reservoir after it's been used. We think that with this high viscosity fluid, there may be the possibility of cavitation of the withdrawal rate on the FPM. So instead, we'd ask you to mop it up with Kim wipes, and you can expect the total volume you're going to have to deal with will be just a little in excess of 100 cubic centimeters. So that will give you an estimate of the amount of Kim wipe you'll need.
I understand that you want us to withdraw as much liquid as we can into the reservoir without cavitation to save as much as possible, over.
No, negative. We ask you never to withdraw liquid into the reservoir. Always, whenever liquid has been ejected into the zone, don't take it back into the reservoir, but mop it up instead with Kim wipes. I realize we're going to lose some fluid, but I think the fluid budget will stand it.
Okay, Mike, the problem is we're running out of Kim wipes. I think that with a large zone we can effectively pull in quite a bit. It's just when it gets down to be a very, very small bubble on the order of 4 to 5 millimeters in height that we have the problem with the cavitation.
Okay, Byron, understood. In that case, you should withdraw always at the slowest available rate.
Yeah.
Okay, we should be LOS while you're doing most of this, so I hope we shall have an opportunity for a short debrief later on in the flight, and I wish you good luck with it. I hope you enjoy playing with it.
Okay, we'll give it a try, and confirm that you want to use dry plates, number 3 and 4 and 5, or number 3, 4, and 6?
That's correct.
Okay, that's very good. We'll do that.
Thanks a lot, Byron. Look forward to seeing you.
Okay, we'll talk to you later.
Voice of Dr. Mike Haynes, 327 Principal Investigator, providing some updated information to Byron Lichtenberg for a rerun of his fluid physics module experiment.
Space Lab, this is Marshall Ops.
Hey, Mike.
There are, of course, 3 boxes of dry wipes in the workbench rack. When you said you're running low, did you mean that you're just about used all those boxes up, or what?
Confirm, we only have about a half a box left.
Okay, we copy. Thank you very much.
There's some in the orbiter, but we've still got about half a mission to go.
Yeah, we copy. Right, okay.
In general, we can withdraw most of the liquid back in there, being careful just when you get down to the end, and I didn't realize that this was a problem early on, which is why we withdrew so much air in there.
Space Lab 327, PI.
Continuing to receive.
Space Lab to Byron, 327, PI.
You go ahead, 327.
Okay, we have a suggestion.
Mike, stand by. We've got some 22 traffic.
Go ahead.
Space Lab ESA 22. How'd you read me?
22. You're late, but go ahead.
Okay, is that Owen or Byron? We think we might have a problem with the last exposure.
Problem?
We think we might have a problem with the last exposure from the timeline, in which case you're going to get an error message. What we'd like you to do is...
Okay, what kind?
You should get an error message, 22A timeline problem, epsilon 9. When that happens, we'd like to use the same procedure as we did in the first performance. Shall I?
Please do.
Okay, we should find the ECAS in step mode, phase 99. What we'd like to do is to leave it in step mode, phase 1, item 51, item 4.2, item 5, whatever time is remaining to sunset, at your judgment, and then item 6.
Okay, I understand, and in order to do that manual exposure for the last one, you want it to be in step, is that correct?
Repeat, please.
In order to run the manual exposure with 4, 5, and 6, you want it in item 52 to be in step or auto?
Step. In step. But we do need
okay,
to have.
I understand.
But we do need to have the high voltage on. It's necessary to go through phase 1.
Okay, I understand.
Oh, and it may not be a problem, but we think we're pushing the envelope on the times.
Graham Bittis, member of the research team for Experiment 22, providing some guidance to Owen Garriott.
And Space Lab, Mike Haynes is back on the line.
Mike Haynes for Byron. Yes, regarding this problem of withdrawal, the reason that we asked you not to withdraw was that some of the PIs that follow are excessively worried about the possibility of having air bubbles in the oil. However, we understand the problem with skim wipes, and so we must therefore ask you to withdraw it, but to do it as slowly as possible, and particularly at the last stages of withdrawal, perhaps to try doing it manually rather than using the FPM motors. Do you understand?
It'll be the heavier viscosity liquid, so we'll keep an eye on it.
Okay, that's fine, and we have a lovely picture of you in the cabin at the moment.
Continuing to receive pre-recorded downlink.
Space Lab, this is Marshall Ops. For anyone? Yeah, we need whoever can manage it to verify that the CPAC depth is Oscar Papa condition, and if it is, we'd like you, or if it isn't, we'd like you to make it OP, and then at the Romeo 5 Juliet panel to switch IU depth to on. You might watch for error messages. You may get some disregard.
You wait about 4 minutes for that. Mike, can you wait about 4 minutes for that until we get this 22 potential problem taken care of and then come back to it?
Sure, that'll be fine.
Okay, after 22 is taken care of, we'll do that.
Real good. Thank you, Owen. And is it okay if we switch on your camera 1 and have a look at you? Get some live video from the cabin, from the module there?
Oh, yes.
Great. We'll bring down some real time.
Space Lab for Byron, Mike Haynes again.
Space Lab. Obviously, there's not going to get all these exposures in before sunset. Do you just expect to cut them off at sunset or keep them running right through the sunset period?
I mean, we should complete on schedule according to what we're seeing. The exposure will be complete before sunrise, so we don't need any more. Please repeat.
Okay, my display only shows half a minute. It's only half a minute till sunrise, but we'll see if it continues.
We've got half a minute and about 16 seconds of exposure, so we're just about marginal, but we're okay. The ECAS 22A would have picked up the fault by now.
Space Lab for Byron, 327 PI.
How'd you go, 327?
Okay, just one more comment, Byron. If we have a chance, if it's still during AOS, then we'd certainly, as always, appreciate mumble mode and any commentary that you can provide. Meantime, we'll be watching the data, we hope. Thank you.
Now receiving live
Space
downlink.
Lab, we're getting live video downlink of the module interior. We can see you guys at work, finally.
22, we just got sunrise, and all the filters have come out, and we did not complete the sixth exposure.
We copy. Owen, thank you very much.
Completed. Thank you, Space Lab, ESA 22.
Byron Lichtenberg working at the fluid physics module, and Owen Garriott at the command and data display system operating experiment 22.
I'll be retracting the camera here in just a moment if you wanted to look at that instead, Graham.
Okay, we copy. You're about to retract the camera into the cell. Okay, Space Lab, this is Marshall Ops. We have some concern about this CPAC activity and wonder if you could right away check that the CPAC dep is op, and if not, make it op, and then at the R5J panel, switch IU dep to on.
Go, I'm doing it right now.
Thanks a lot.
Now you're depth on.
Hey, thanks a lot, Owen. Real
It
good.
was knopped, and it was knopped, however, and now it's up. And IU depth is... Byron turned it on.
Okay, thanks a lot. We copy. Here, go to retract 22 into the cell.
Standing by for a retraction of experiment 22, the wide field camera, which has been photographing ultraviolet emissions from various astronomical sources during this night pass of the orbiter. Must be retracted into the SAL and the cover closed to protect the camera during the daylight portion of the orbit.
And Owen, we saw you just bring the experiment inside the SAL.
Gotcha.
And Space Lab, this is Marshall Ops. We watched that retraction using a payload bay camera. That's really smooth. You guys have your act together.
And we have you on TV inside the module again.
Owen Garriott finishing his activities with retraction of the wide field camera and closing the outer hatch. Byron Lichtenberg just completed some stowage as he continues to work now at the material science double rack.
Okay, Space Lab, this is Marshall Ops. We need you to turn off the IU dep switch on the Romeo 5 Juliet panel for CPAC, if you could do that now. Real good. Thank you very much. We still got you on real-time downlink.
And here in the payload operations control center, the experiment 22 investigator team consulting following another operation of their experiment.
And Space Lab Marshall Ops, we're getting ready to go LOS, and we'll see you over Guam at about 6+34.
Okay, talk to you later.
And Space Lab in the blind, check and make sure the outer hatch is closed.
I'm closing it now, Bill. Thank you.
This is Marshall Space Lab operations at 5 days, 6 hours, 14 minutes mission elapsed time. We have loss of signal with Space Lab through the tracking and data relay satellite the next acquisition will be an orbiter MOCR-only acquisition, no payload communications between Payload Control Center and Space Lab because the next pass is a UHF-only pass. During the last acquisition of signal, we received a considerable amount of live downlink television as well as some pre-recorded television. We received television of experiment 22, the very wide field camera being extended from the scientific airlock. Then later we received television of it being retracted into the airlock following its operation. Additionally, Graham Bittis, one of the investigative team members for the experiment 22, was enabled and spoke with the crew about operation of that experiment. In the Byron Lichtenberg operated experiment 327, actually a modification to that experiment, one of the material science experiments using the fluid physics module, and the modifications to that experiment were provided by Dr. Haynes of the University of Bristol, the United Kingdom, who is a principal investigator for the kinetics of spreading and wetting of liquids. We received some downlink television from inside the habitable module of the 327 preparations in operation. And additionally, we received some pre-recorded views of the Earth from the payload bay camera. At 5 days, 6 hours, 16 minutes mission elapsed time, this is Marshall Space Lab operations.
This is Mission Control Houston. We're configured now to acquire the air-to-ground with the orbiter and mission audio during this next pass, which is through Yargity, which is a UHF only. We'll acquire there in about 3.5 minutes, and it's a fairly long UHF pass of 7.5 minutes duration. During the previous pass, things were still quiet on the flight deck, but Capcom Anna Fisher did advise Columbia pilot Brewster Shaw that the mission had been extended by 1 day. Shaw said that's good news when told that the mission control team would be assembling a timeline to budget their activities for the following day. Brewster encouraged them to use some time to use up the film that's remaining on board to give him the opportunity, and also he said the PSs and the MSs should have the opportunity to do some photography out the windows. And Capcom acknowledged that suggestion and assured them that the control team would take that into consideration when working up the flight plan for the extra day. We'll have AOS through Yargity in about 2.5 minutes. At mission elapsed time, 5 days, 6 hours, 18 minutes. This is Mission Control Houston.
Okay.
Columbia, Houston, with you through Yargity for 7.5 minutes.
Loud and clear, Anna.
Yeah, Brewster, and for your info, during that last TDRS pass, I just want to let you know that you lost your S-band power amp 2. PA1 is working okay, and there's no impact other than loss of redundancy, and your switches are configured properly.
I missed the last sentence.
And just in case you were wondering, your switches are configured properly.
Okay, fine.
Columbia, Houston, with you through Yargady for 7.5 minutes.
Loud and clear, Anna.
Yeah, Brewster, and for your info, during that last TDRS pass, I just want to let you know that you lost your S-band power amp 2. PA1 is working okay, and there's no impact other than loss of redundancy, and your switches are configured properly.
I missed the last sentence.
And just in case you were wondering, your switches are configured properly.
Okay, fine. Well, I hope the MTBF on power amps is not 5 days.
We copy, Rooster. And Columbia, Houston, that's only loss of redundancy on the TDRS S-band downlink, so that's no problem with G-Staten sites.
Okay, understand.
Your KU band's working fine for downlink.
Okay. Say, Anna, I have a question for the crew equipment folks.
Stand by, Brewster. Let me make sure they're listening. Okay, go ahead, Brewster.
I remember on STS-9, they had some very large, clear plastic bags on board, about the same size as you would use for lawn trash bag. And I want to know if we have any, and if so, where to find them.
Stand by.
Okay, thank you.
They're working on that, Brewster, and we'll get back to you as soon as we can.
Okay, no hurry.
Columbia, Houston, we're going LOS. We'll see you again through Guam at 6+3-4 after we send up some teleprinter messages.
Okay, fine.
This is Marshall Space Lab operations, 5 days, 6 hours, 34 minutes mission lapse time. Standing by for reacquisition of signal with Space Lab through the Guam ground tracking station in just under a half a minute. Presently, the orbiter in Columbia on the ascending node of the 86th orbit.
And Space Lab, Marshall Ops, we've got you at Guam for about 6 minutes.
Okay, Bill, I got you loud and clear. And Marshall from the Space Lab, advise Mike Haynes at 327 PI that his discs number 2 and 3 have got some sort of a burr or scratch on part of the surface of the disc, over.
Okay, we copy, and Mike Haynes should be on the line.
Oh, another question. You have me scheduled for an AV2 tape change-out. I can still do it later. I haven't started it yet because it's got so much time on it. I thought you might want to use it a little bit later. So I just leave it on there for a while and use it for some FDM stuff or something like that?
Yeah, just hold on that, Owen.
I'm going to be up getting some chow out, so I will be back. Byron can take the message.
Roger. We copy.
Space Lab to Byron, 327 PI.
Roger, go ahead, Mike.
Byron, could you repeat the problem that you have about the disc?
Roger, 2 of your discs number 2 and 3, have some scratches on the surface of each one of them.
Okay, Byron, I think that the presence of the scratches is going to be less important with the more viscous oil, so I don't think you need to worry about that.
Okay, very good.
Thank you.
Space Lab, this is Marshall Operations with some news about the VITR tape dumps, if anyone is ready to copy. Oh, okay, Byron, if you're there, the news is that we'll not be asking you to change any tapes. We've already managed to dump everything that we have on VITR number 1, and as soon as we get our command capability, we're going to rewind that, and you'll be able to use VITR number 1 without any change-outs. Concerning Owen's question about number 2, we're going to be able to rewind that and dump it ourselves so that we won't need you guys to change out VITR number 2 either.
That's good news, Mike. Thank you. Mike, we're finally set up and ready to go here with 100 centistoke tracer fluid.
Okay, Byron, we're listening with great interest. Good luck.
And Space Lab for Marshall Ops, Byron, we need to do one of these song and dance Op 14s on Route 14.
Go ahead, Bill, what you want? Op Route 14, is that right?
That's affirmative. And Owen, at about 7 o'clock, we're going to be doing some CPAC troubleshooting, and we'll have the CPAC people on the line. And Space Lab, we've got you for about 1 more minute, and we'll see you at about 6 plus 55.
Hey, should have some news for you by then. Gonna be re-opted.
Okay, we copy. You've got it opt.
This is Marshall Space Lab Operations at 5 days, 6 hours, 41 minutes mission elapsed time. We have loss of signal through ground tracking station, anticipating reacquisition through the tracking and data relay satellite in about 13.5 minutes. During the last acquisition, Mike Haynes of Material Science Double Rack Fluid Physics Module Experiment 327 was enabled briefly and talk with the crew as they continued to work on operations for that experiment. Otherwise, things proceeding as normal here in the Payload Operations Control Center, where approximately 100 scientists are on duty, along with the payload cadre, operating both crew-involved experiments as well as experiments being operated automatically by the Space Lab computer. Approximately 12 minutes remaining until reacquisition through TDRS. This is Marshall Space Lab Operations. This is Marshall Space Lab operations at 5 days, 6 hours, 54 minutes mission elapsed time. Standing by for reacquisition of signal through the tracking and data relay satellite with Space Lab in just under half a minute, or just over a half a minute. Presently, Space Lab in the orbiter at the apex of orbit number 86. On board crew Owen Garriott, scheduled to be continuing with experiment 22, very wide field camera operations. And Byron Lichtenberg, scheduled to be conducting some replanned activities, troubleshooting with the space experiments with particle accelerators experiment. That experiment had been experiencing some difficulties earlier in the mission with their electron beam accelerator. Standing by now for reacquisition of signal.
And Space Lab Marshall Ops, we've got you for about 48 minutes.
Okay, Bill, we got you.
And Byron, if you have any comments on Mike Haynes' experiment, we have him for about another 2 minutes.
Okay, very good. Yeah, I got quite a bit, Bill. Mike, are you there?
Yes, I'm Byron.
Okay, I went through and did your first run, and I drew a drop which grew very nicely out to point Alpha 2. Coming into Alpha 3, the drop did not contact the front plate, so I had to drive all the way into front plate positions of 4.5, reservoir 3.3. I was able to film the contact, and then I went to point A4, which very nicely grew what looks to be a catenoid, and just after the both reservoir and front plate stopped, the neck started necking, so I was able to catch the rupture of that in cine mode also. I've brought the take cine pictures of the reforming.
Space Lab for Byron, Mike Haynes in the blind. We're having a long gap in communications at the moment.
Okay.
Space Lab for Byron once again in the blind, Mike Haynes. I've read you up to step Alpha 4, and I understand you've achieved considerable success. Thank you very much indeed. I'm very happy even with this partial report, and I look forward to hearing some more on your next pass. Out.
Okay, Roger. Well, we'll try and do another disc with the Bravo settings here shortly.
Okay.
The only complaint I can see is even after shaking it, I don't see any tracers in the 100 centistoke fluid.
I understand you see no traces in the fluid, correct?
CPAC for Owen.
Byron.
CPAC for Byron.
You go ahead, Bill.
Roger, Byron, CPAC. We'd like to load O2A now and turn our IU dep on as soon as you get the O2A loaded.
I'm sorry, you...
Byron, this is CPAC. We'd like to load O2A now and then turn IU dep on.
Marshall Ops, this is Space Lab, and I've just loaded 22 Alpha, as according to timeline, we do not have time to load the CPAC applications tab. We don't have any room in memory to load the CPAC applications test. Marshall Ops, how do you read?
Owen, we copy it and we're looking at it.
Yeah, I'm down to 4,600 words, and obviously that's not enough.
Owen, we copy and we understand.
Just this time.
And Space Lab Marshall Ops, we're showing 7456 on your ECAS now.
Okay, that's right. Now we can do it. We couldn't when you first asked.
Real good.
Roger that.
Do you want me to load CPAC applications?
That's affirmative. O2A. And CPAC for Space Lab, we'd like to wait until we have KU band before we turn the IU dep on.
Okay, understand. Just give us a call. I guess this is Roger, whenever you're ready.
It's a Roger. And let me voice up now what we're going to do in this procedure.
Head ready to copy.
Roger. We're going to run model number 8 with checklist -4. The T0 is day 337, 23:35:00 GMT.
I understand. I think the only other thing we need to run it manually is a STL for the exception monitor.
Roger, and we're going to have to do some inhibits, Owen. Sierra 02 India 00 is the exception monitor timeline. Panel switches are nominal. And in the PCF, we're going to do negative SMO. We're going to select a beam voltage factor of item 9, 32 enter, item 10, 02 decimal, or disregard. That's beam factor voltage is item 9, 32 enter, item 10, 0.2 enter. And we're going to have a heater current, item 5, 16.0 enter. We then need to inhibit all of the shutdowns. There will be 6 items, EBA, PWR, DGP, MTV, MPD, and all shutdown.
And Space Lab, this is Marshall Ops. We need you to start experiment 22, 3 minutes earlier. Copy?
Negative, CIC.
No. Disregard that message.
And CPAC for Space Lab, we would like IU dep on now.
Voice of Roger Williamson, CPAC co-investigator, providing guidance on troubleshooting procedures for that experiment.
And Space Lab, this is Marshall Ops. We want you to start experiment 22 at 23:18:30 Zulu time. And if you copy acknowledge on the scratch pad line, I think we've lost down.
Okay, Space Lab, yeah, we read your scratch pad line, thank you. I guess we have one Wacom.
That reference to a response using the experiment computer. Crew unable to communicate by voice apparently
And
at this time.
Space Lab, this is CPAC. We need IU dep on now.
We can't turn it on until we get the messages typed into ECAS, guys.
We copy that the IU dep is now on.
How do you read now, Mike?
Hey, good copy, Byron, thank you.
Hey, we kept getting your copy up here from the CPAC guys, but we couldn't turn the dep on until we had the typed messages to the ECAS, over.
Yeah, I see, we understand. And I believe CPAC is enabled for a voice with you, and you should be able to hear him.
Hey, we've been hearing them. Got a dep ready, yes, that's good news.
And CPAC has a dep. And we're looking good, Space Lab. We've got a yes, fantastic. We've got dep ready, yes, Space Lab.
It looks good. We were unable to copy all of your PCF changes, so please go ahead and re-uplink them.
Roger, we need negative SMO, and then beam factor voltage. That's item 9, 32, enter. Item 10, 0.2, enter. You copy?
Copy.
And the heater current, we're going to toggle. We'd like to start with item 516.0, enter. We also must inhibit the shutdowns. That will be an item 15, EBA, enter. Item 16, enter. Followed by shutdowns on PWR, DGP, MTV, MPD, and all. How copy?
Okay, I've got PWR, MPD, MTV, and all. What is the other one, please?
The EBA and DGP.
Okay, copy.
And we copy your 16 ampere heater current, Spacelab.
That's what you wanted, correct?
That's affirm. And later on, we may ask you to go to 0.0 and immediately back to 16.0 if we have a problem. And Spacelab CPAC, we'd like MTV on manual to take a look at the EBA heater.
Okay, we copy. Okay, guys, that's what I thought. We can't do an auto inhibit of all, but I've got...
That's okay, Spacelab.
Victor, Delta, Golf Papa, all inhibited.
Experiment 2, co-investigator Roger Williamson passing some...
And Spacelab, this is CPAC. We are not able to confirm the beam factor voltage. That was item 932.
Stand by.
Williamson's providing some...
Roger, reading decimal 200.
Confirm.
assistance in this attempt to run the CPAC experiment. Initial indications are that at least the dedicated experiment processor is communicating through RAL 21 at this time.
And Space Lab, CPAC is ready for a proceed.
Okay, here we go. Here we've got the experiment prep on.
And we confirm prep on.
It's looking good. Battery go, bat volts at 44.
And Space Lab CPAC will be listening for anything you see in MTV as to a glow on the EBA heater.
Hey, Roger, we copy. Marshal Ops, Space Lab.
Go ahead, Byron.
Roger, Bill. We'd like to know if the INCO people are going to route the vid, the 02 analog data to the tape recorders, or should we do it? Over.
We're talking to DMC right now.
Okay, great. Hey, we've got MTV up, CPAC people, and there's still too much reflected sunlight in the bay to tell whether the heater's on yet.
Okay, we copy, and we'll be looking here too.
And Space Lab, this is Marshal Ops for Byron. We've taken care of routing the digital data for CPAC, and I think we're just going to go with that for the time being, unless CPAC makes another call. By the way, I have some messages for Byron, particularly marking up his PCAP when you come to a place where you can copy for a couple of minutes.
Well, okay, this is a good time as any.
Okay, Byron. We have a long list of things we'd like you to do in the next couple hours, and if you're ready to copy, I'd like to just sort of walk through the things that are on our shopping list. When we're done with this CPAC run at about 7 hours and 40 minutes, we'd like you to take the next threshold level run for experiment 340. That's the UHV chamber, part of MSDR. and I can give you the keystrokes that you're going to need there in order to get that run started, if you're ready to copy those.
Go ahead, Mike.
Yeah, what we'll need is an open 102444, enter, followed by a close 000060, enter. And at that point you should find that the UHV operations lamp flashes, and when it does, give it a resume UHV enter. And that'll give us a run of several minutes, we believe. This entry is a little bit smaller than the threshold that we walked through last time, and the team here is interested in seeing what happens. That ought to take you 5 or 10 minutes. As soon as you're done with that, we'd like you to try one short minimum cylinder run for Isidoro on experiment 331. We have 3 steps that we'd like you to go through, having to do with formation of a cylinder. Are you ready to copy those?
Guys, commanding 13.
And Space Lab CPAC, we need to go to 0 heater current and back to 16 immediately. That's an item 5, 0.0 enter, followed by item 5, 16.0 enter. Copy?
That's already done. Look like it changed back to 0, though. Try that again because I got a syntax error here.
Roger. We want to do an item 5 to 0.0, turn the heater off, and back. And we're copying now.
Well, it won't take it.
Okay, let's try an item 932 enter. Correction. That's an item 934 enter for the heater with an item 10 0.0 enter.
Okay. Looks better now. You've got to type in a 00.0.
And we confirm 0 heater current now.
Hey, you ready to go back to 16?
Affirm, immediately after.
Yes, you got it.
Right, we confirm. We'll give you, Space Lab CPAC will give you another call in about 3 minutes to do the same thing. We'll want to go to 0 heater current and right back to 16 for a heater current.
And Byron?
Marshal Ops Space Lab, but...
yeah, go ahead, Byron.
You guys get the 13 message?
Yeah, Byron, just disregard all 13 messages right now.
And Byron, I have a few steps on that 331 experiment whenever you're ready to copy.
Go ahead, Mike.
Yes, Byron. What Isidore would like you to do is what he calls a minimum cylinder run. It's just 3 steps. First, he'd like you to have both 40 millimeter discs in reasonably clean condition, rotating at 5 RPM as an initial condition, using his diagram 331A-5. His second step is to go from the origin O to point Peter in order to build a cylinder, and you may have to go real slowly along there in order to do that. And the third step is to follow the sequence of points from Peter to Bravo, from Bravo to Nancy, and from Nancy to Kilo, exploring the stability of those cylindrical configurations. If you succeed in doing that, that'd be terrific. We don't have a lot of time for you to spend on that minimum cylinder run because we have a couple other things for you to do. Earlier, we linked up a power supply maintenance task for the IHF and IHF and MHF combination of the MSDR. And what we'd like you to try and do as soon as you've taken care of Isidoro is to go through those steps involving switching off the heaters, removing the front panel, disconnecting J5 and J7, and going through the opens and closes, which I linked up earlier and which I believe you still have.
Mike, on the UHV, I think you skipped a digit on the open. Give me the open entry for the UHV again.
Sure. I'll read it to you right now. The open entry is 102444. And here comes CPAC.
Okay, thank you.
And Spacelab CPAC would like to toggle the heater current again. You're going to try item 500.0, enter, followed by item 516.0, enter. Copy.
Roger, that's in work. The MSCR people, we've got the UHV started again. Steady ops light.
Real good, Byron. Happy to hear that. Spacelab, this is Marshal Ops for Byron with a couple more notes. When you've taken care of that power supply and got that datum for us, we'd like you to get started on experiment 329 Bravo, John Paday's experiment. We'll have becoming AOS sometime along about then, and we'll have John Paday standing by to discuss the progress of that experiment with you. In fact, your go for 329 ops really for the rest of your shift, right on up to handover. And we hope it's a successful run that you get there.
Okay, well, I hope you guys have it set up. I'd like to do whatever runs I can do with 100 centistokes with tracers. It's such a big job to replace one of these reservoirs.
Okay, we copy, and we'll tell that to John.
Okay, well, also for Isidoro, the 100 centistoke fluid seems to be much better behaved than the 5 centistoke.
That's, of course, a real useful observation. Do you find that there's less turbulence or jet action in the liquid stream when you're trying to push liquid out of the reservoir?
That's exactly correct, and it's much easier to handle. I was able to rejoin Mike Haynes' column, and after I rejoined it, it went over the anti-spread, but by 5 RPM rotation, it came back to the middle. And I was able to get all the fluid back in, the little last bit using the manual injection knob.
That's real good news. I'm going to have to give air to ground 1 back to CPAC now. Thanks for that fact.
And Spacelab CPAC, looks like you might be in the darkest portion here. Is any chance MTV is showing you something?
Well, I have a glow on both edges of the EBA assembly, but I think it looks like sunlight. It's really hard to tell.
Okay, we copy.
Looks a little more like...
And we'd like to toggle the heater current once more.
The break for 22, experiment 22. The last exposure, when it came in, it set a exposure time of 480 seconds, which seems to me is too long. I was expecting another 180-second exposure. Could you confirm if that's what you wanted?
Okay, we'll work that with 22 on and be right back with you.
Okay, CPAC, the latest toggle was done, and watching the EBA on the MTV, I didn't see any change at all in the brightness level.
Okay, we copy, and we confirm the toggle of the heater current.
Sorry about that.
Right.
Okay, Owen, we want a 480 exposure time.
Okay, that's what we got, and I see, I think it's just a typo that showed up on target Charlie line on page E0-5, so I think it's going to all fit within the time limit, okay.
We copy, thank you.
And Spacelab CPAC.
Go ahead.
We'd like to go ahead and do one more toggle before we come up on T0 at 3-5 after. And we'd like to turn off the MTV manually before we come into sunlight.
Okay.
And CPAC confirms the toggle on the heater current.
Mike, that's the UHV stop. What's the next threshold, 50?
Yes, exactly, Byron. You're reading our minds down here. I can give you those keystrokes if you'd like them again.
It's okay. I got it.
I figured you would. Thanks a lot, Byron.
ESA engineer Graham Bitt is reporting to Ops Controller Beau Chanel that just finished another run of Experiment 22, and from the housekeeping data,
HVC restart complete.
things look real good on that experiment.
HVC shutdown. VA shutdown complete.
We copy.
CPAC, marshal ops.
Byron, do you want CPAC?
I'm going to inhibit the MTV.
Affirmative, Byron.
Okay, you guys want me to go ahead and shut it down?
Affirmative, Byron. And could you confirm that we had an EBA inhibit?
Okay, yeah, I can.
And Space Lab, this is Marshal Ops with a note for Owen and his PCAP whenever he's ready to copy, or anyone's ready to copy.
I'm ready to copy, Mike. Go ahead.
Yeah, right. Owen, we'd like you to do the TV 21 setup to show the FPM activities coming up in the next rev. Sometime when you're done with this 22 run and before the next night's 22 run.
Okay, be fine. I'll do that.
Thank you kindly.
First, okay. Mike, we got the UHV going with a 50.
Real good, Byron. We copy that you got the UHV going. Does that mean that the UHV ops light is on steady?
It just started, so let's see what happens now.
Okay, terrific. As you figured out, we are just working our way in threshold down from 60, 50, 40, and so on.
You got it. I'll keep you informed.
Thanks a lot.
Understand that I'm going to go ahead and terminate Mike Haynes now and go on to Isadora, right?
That's right, yeah. Isadora, I'd like you to build a cylinder, if at all possible.
Okay, we'll try it.
Thank you very much.
And Space Lab CPAC confirms FO complete.
Okay, Roger, we got it also.
And Byron, CPAC's ready to go ahead and shut it down. We can use the checklist Delta Tango -14.
Okay, that's in work. It's just about complete.
Copy.
And as soon as we lose communications here in about 5 minutes, we're scheduled to have a science update on the very wide field camera operations that have been underway this afternoon with the principal investigator for that experiment, Experiment 22, that's scheduled to begin approximately 5:45 p.m. Central Standard Time. About almost 5 minutes remaining in this acquisition of signal with Space Lab.
And CPAC for Byron, we want to confirm the method of shutting down the MTV. In the past, we've used the last 3 steps in MAL 2.9 as a means of shutting it down.
Okay, stand by. Roger, that's affirmative. The MTV, Mike Tango Victor, was shut down in accordance with MAL 2.9.
Roger, we copy, and thank you very much.
Marshal Ops, Space Labs, the CIC.
Yes, go ahead, Byron.
Bill, if you could tell Mike Haynes that his film magazine 329 Bravo has about 800 frames used, okay? So there's still about 1,200 to go, 1,300 available.
Roger, we copy. Thank you, and Mike appreciates that.
Marshal from Space Lab, can the CPAC folks tell us if they've...
Oh, and you dropped out?
might be the situation with respect to that EBA heater. Do they think that it never has come on, or that it has come on and burned out, or they just can't communicate with it? Over.
Owen, this is CPAC. The heater appears to not come on. We can't tell if it is burned out or not. The characteristics of the failures that we had earlier were not indicative of a burnout. We did get very small emission during one of the sequences, and we're still looking at what possibilities we have for that heater, but we're not very optimistic at this point about being able to recover the heater. Copy.
See at 8 plus. See at 8 plus 29.
This is Marshall Space Lab operations at 5 days, 7 hours, 46 minutes mission elapsed time. Loss of communications with Space Lab through the tracking and data relay satellite. Reacquisition will be, next reacquisition will be again through TDRS, about 41.5 minutes. During the last acquisition period, Mike Haynes, principal investigator for one of the fluid physics module experiments being conducted in the material science double rack, was debriefing Byron Lichtenberg on operation of his experiment, kinetics of the spreading of liquids on solids, and that particular operation was actually a modification of an earlier run of that experiment. Also, during much of this acquisition period, Roger Williams, co-investigator for the CPAC experiment number 2, was communicating with the crew regarding operations of that experiment. Byron Lichtenberg was working with Williamson. This was an effort to attempt to operate CPAC to troubleshoot an apparent problem with the electron beam accelerator, which has been narrowed to a search for the problem in the EBA heater. Early on, they were able to establish communications with the experiment out on the pallet through Row 21. However, at this point, they were unable to get a positive indication that the heater was operating. Meanwhile, Owen Gary had operated Experiment 22, the wide field camera. That operation involves extending and retracting the camera from the scientific airlock and taking exposures of various lengths. Part of these exposures are actually controlled by the experiment computer. Principal investigator, or the team of investigators here in the Payload Operations Control Center, looking at the housekeeping data from operation of that experiment, and Graham Bittis, a European Space Agency engineer, indicating that the housekeeping data looked good, and that was a good indication that the experiment is operating properly. We have just under 39 minutes before we reacquire through the tracking and data relay satellite. 5 days, 7 hours, 49 minutes. This is Marshall Space Lab operations. This is Marshall Space Lab operations at 5 days, 8 hours, 27 minutes mission elapsed time. We're standing by for reacquisition of signal with Space Lab through the tracking and data relay satellite in under a minute now. During that acquisition of signal, we are anticipating some downlink television from the habitable module. This television scheduled to be of the fluid physics module operations being conducted by Byron Lichtenberg. However, there's a possibility when we begin receiving that television that payload specialist Lichtenberg will be still working with a workaround for the power supply that provides power to the isothermal heating facility and the mirror heating facility. That power supply went on the blink earlier today.
And Space Lab, this is Marshal Ops. We got you for about 51 minutes.
Okay, you're loud and clear, Bill, and the TV is set up.
Okay, we copy.
Marshal Ops.
Go ahead, Byron.
Okay, Bill, one quick thing here before we get going. I was over here reaching for the mini-lab rack, and I tripped off the 101 circuit breaker, the 28-volt circuit breaker.
Okay, we copy.
And what I've done since is to turn it back on, reset the Apple computer, and give it a restart. And let me read you the housekeeping data right now, okay?
We're ready to copy.
Yeah.
Okay, left rotor is 52.5, right rotor is 59.4, 24.6 each. And the HET time keeps jumping around. It's now 170 hours, 17 minutes, and a while back it was 658 hours.
Byron, we didn't get those RPMs and temperatures.
Okay, the RPMs are down around 59.5, and the temperatures are nominal at 24.6. What concerns me is the heat flux elapsed time, which keeps jumping around between 170, 402, 658. Now I've got rotor speeds of 75.6 and 68.1.
Okay, we copy.
The HET just went to 402.17.
It sounds like that's sort of an erratic display there.
I think it's something erratic in the computer.
Okay, thank you very much, Byron. The SMA copies that. Wonder if you got any further with the UHV workaround.
I'm down to 30 now, Mike, and it's just started it up again.
Real good, Byron. Thanks a lot.
And Space Lab for Owen.
Go ahead.
Yes, Owen, on this next 22 run, we would like to have you start at 30 seconds early.
Problem, Wilco.
And I've got to read up to you some exposure sequence changes.
And?
Okay, let me give them to you for Delta. It should read 3/100, 1/400, 1/400, and this is a change, 2/400, and this is a change, 2/100.
Okay, is that the upcoming run or the following after that?
It's for this upcoming run, Owen.
So do you want me to run them all manually, or how do you want it run?
It'll be automatic, Owen.
I see. Those are the different from the stuff I got in the flight plan.
Yes, if you've got the your procedure handy, page 22 EO5, we've got some more to pass up to you also.
And Space Lab, this is Marshal Ops. Be advised that we're about to take some
too long, Bill.
Some live downlink video, if it's all right with you guys.
Okay, Mike.
We copy. Thank you.
And Byron, or Owen, I didn't copy your last transmission.
Standing by now for live television from inside the Space Lab habitable module.
CIC Space Lab, over.
Go ahead.
Okay, these changes that you gave me are already into the software, so I don't need to make them. Is that correct?
That's affirmative. We've got two that aren't, though, Owen.
Okay, the last two that you gave me, you want me to make those changes?
Yes, I've got one for Charlie and one for Golf.
Okay, I'll have to figure out what you mean by that. But
okay, that's your target, Owen, and they're on page 22 EO-5.
Okay.
For the
we already did target Charlie on the last night pass.
I know, and you caught the change on Charlie of 480. It was 180. We changed it to 480.
You got me a little confused at the moment, Bill. I'm not sure now whether you're telling me I need to make a change or just to alert me to the fact that there have been changes made. Over.
There have been changes made, Owen, that will affect the red shift that's coming on, and we'd like to read these up. They'll need them when they come on shift.
Okay, fine. Now I understand, and give me we can do them during the time of the pass here. We have plenty of time.
Okay, we'll give them to you later.
Byron Lichtenberg now setting up one of the television cameras in the Space Lab.
Did you copy all of the CPAC information in the last transmission?
We didn't have a recent transmission from CPAC, so I'm not sure I have what you want.
Okay, they gave a debriefing of the status of the CPAC instrument. Did you get all that information?
I think I did. They told me the status of the filament.
Okay, we do have the 329 PI enabled for this pass, and also the 22 PI enabled.
Camera just set up by Lichtenberg to...
Bill, let me give you a quick brief on 331 here, okay?
Go ahead.
Are you guys getting any live TV?
That's affirmative.
Okay, well, if you put on camera number... So the one that's looking in the fluid physics module, you can see the fluid in there with the tracers reflecting it. It's not a great one. Camera 2.
Okay, we'll try to get on camera 2.
I did what y'all wanted. I started spinning it, and I went from 0 to, or Oscar to Papa, and then Papa to Bravo, and by the time I got to Bravo, the fluid had spread out all over the disk. I am now Bravo to November. I'm at November, and I'll go ahead and rotate it for you a little bit. You can see how asymmetric it is.
Roger, and we're watching it now on TV.
Okay. About some, it's pretty tough to get the light set up for the TV.
329 PI here. 329 PI, Space Lab. I'm watching the TV. .329 PI here. Am I enabled?
Either the settings or something, but
okay.
Anywhere close to a 40 millimeter cylinder.
I'm watching what
also,
you're doing.
Okay. This is still, we still got two 40 millimeter discs and the 100 centistokes with tracer fluid in here. My reservoir and front plate positions are almost equal now, so that I shouldn't have any fluid left in there. My feeling is that there were some fairly large air bubbles in that reservoir when it was launched, because either that or it moved and expanded, because I didn't suck any fluid in except I could see what I was doing when I did Mike Haynes' run, so that I was pretty sure that I didn't suck any air in it, but there's quite a bit in there, obviously.
Okay, Byron. I've seen this and copied it. I think the thing to do now is to wind down on this one and start 329 option B, but I'm afraid it involves a reservoir change. I know you don't want this, but it's impossible to run the experiment without the 5 centistokes, no tracers. So I guess the thing to do is for me to leave you to it now, but will you please stop at step 144, repeat, step 144, that's the end of the setup procedure, because then we operate manually on a step-by-step basis into option B, but omitting, repeat, omitting step sugar 1. It is important that if we go...
Wilco,
Okay.
I'll stop at step 144, John.
Okay, Byron, we need somebody to do an op on Route 21. And we have you back on camera TV1.
In the field of view, the material science double rack, fluid physics module. The experiment Lichtenberg working with in that module, capillary forces in a low gravity environment provided by the United Kingdom.
Be advised, we got that UHV stop again.
Yeah, Byron, whenever you get a moment, you can go on the next step, which is the same deal except with a 2-0. And when you have a minute, of course.
It'll be a while.
Right, I understand. A little later, when you get a chance, we were interested to see if you did any of the maintenance on that power supply.
And here in the Payload Control Center, Dr. John Paday of Kodak Research Laboratory in the United Kingdom, following along as Lichtenberg is performing his experiment.
I'm not sure exactly, Mike, what's happening with the, or John, actually, John Paday, 329. What's happening with the reservoirs, but an awful lot of bubbles in here.
Byron, can you tell me whether we're talking of the bubbles in the high viscosity with traces or the low viscosity 5 centistokes reservoir?
It's the high viscosity.
Can you remove the high viscosity and change it to the low viscosity 5 centistokes, please?
Roger, we'll do that.
Here in the Payload Control Center, Paday and his team monitoring Lichtenberg's progress.
Roger, Space Lab. It looks like 22 is running fine, although the exposures and times are certainly not following the data on our page E05, and I presume that's the information you were uplinking a moment ago. Over.
That's affirmative, Owen.
Now, do you have any other information that you want me to tell the red shift about changes on page E05, or just tell them not to pay too much attention to what we have tabulated there?
We will, if there are any changes the red shift needs, we'll have them uplinked to them, Byron. Or Owen.
It's uplinked by teleprinter, is that what you're saying?
Yes, they'll come up on the teleprinter.
Okay, sounds fine. The experiment seems to be running very nicely. Everything's going as quick as a whistle.
And the 22 team says it looks like a fine run, Owen.
Okay, fine. I'll be out of the module here for about 30 seconds, and I'll be right back.
Copy.
I'm watching you on TV, Byron, and I realize the problems you've got.
Right.
Byron Lichtenberg in the process of removing one of the reservoirs from the fluid physics module and replacing it with a reservoir containing fluid with thinner viscosity. In the process of mopping that up right now. Dr. Paday had requested him to change the reservoir and put in a one that had fluid with a thinner viscosity. Fluid physics module with which Lichtenberg is working is part of the material science double rack provided by the European Space Agency for the Space Lab 1 mission. One of 4 facilities within the rack.
Don't worry about answering me, Byron, but we're all learning a tremendous amount down here about design of apparatus.
Space Lab, this is Marshal Ops for Byron.
Mike?
Yeah, Byron, can I interrupt your FBM activities for about 1 minute over at the HeFlex experiment? They've devised a workaround for that power glitch, and just a few switch throws. If you can put things into a stable configuration, I'll just read you a few steps.
Roger, go ahead.
Good. First thing we need on the HeFlex experiment is the experiment power switch turned to off. Good. Can you now confirm that EPSP-10 DC2 switch is in the on position?
It's on.
Good. And can you check that circuit breakers 12 and 28 are both on? Good, and I also need to check the HEFLEX mode switches to normal. Is that correct?
Confirm.
And how about battery switch? That should be on off, is that right?
Off.
Great. I now need you to switch the experiment activate standby switch to standby, please.
Right.
And I need the left and right rotor switches turned to off. Good, and now I need the clock power switch set to off.
Right.
Real good. We can also follow you on real-time video, so that simplifies things. Now, I need the HEFLEX power switch moved to on. And the experiment switch set to activate. Real good. Saw you do it. Now I need the left and right rotor switches moved to on. Okay, and now I need the clock power switch moved to on. Terrific. That's done an excellent thing. We now need you to press the reset button and then press the lamp test button. Okay, Byron. That concludes this restart of HEFLEX. Thank you very much for your time. Let me turn it back over to the FPM team and John Paday's experiment.
So we have to press start.
Yes.
Byron, John Paday here. I'm watching and I can't quite work out whether you've got the reservoir in yet.
Doors in.
Roger.
Lichtenberg just completing a troubleshooting procedure on the experiment 101.
Looks great. Thanks very much.
Sorry about that. Really my fault. I blew it.
Don't worry, we're back on the track. Thanks for your help.
Experiment 101 is the plant growth experiment. Mutation of Helianthus annuus in microgravity using the blue rack, the Life Sciences double rack, which is right next to the material science rack.
And for the 331 investigators, you can report. We got 331 Alpha in here, and we have about 800 frames used on 331 Alpha now.
Okay, Byron, we understand.
Byron Lichtenberg just removed the film pack from a camera used to document the fluid physics experiment activities.
Johnny, can you give me a quick confirmation, John Paday, about your film magazine 329 Alpha? Is that the first one to use?
Yes, that's right. We've got plenty of frames on that, and it should be perfectly okay for this and other experiments.
Lichtenberg now in the process of installing the film pack for John Paday's experiment for documentation of that experiment.
The F-stop is F8, Byron.
And Space Lab, we need another op on Route 21.
Okay, Bill.
Okay, we copy. You've done that.
Lichtenberg has reinstalled the film magazine and is now in the process of installing the motion picture camera that will be used to observe the fluid activity during the experiment. He changed reservoirs that contain the fluid for the experiment, and also changed film magazines from a previous experiment. This is a multi-user facility, several different investigators using the facility for different experiments.
And Byron and Owen, if you haven't suspected, the reason for the ROW 21 op commands is to help us obtain some experiment operations. Every time somebody goes through the ROW, we end up having to do that. And it's suspected that the ROW has a thermal problem also.
I think I should most of that, Bill. You say it's got a thermal problem, but every time somebody has to tries to use the route, you get that. Is that what you were saying?
Yes, that's affirmative.
Okay, thank you. We don't mind. It just takes a moment.
Byron, John Paddy here. I'm watching carefully, but I'm not commenting so that you can save your energies for the setup.
Byron Lichtenberg removing the disc plate from the end plate from the module, and we'll be installing a new end plate. These are the discs that are used between the fluid bridge that was observed earlier. Is spread between these two plates inside the module.
Hey, John, we're getting close now. There's that army Velcro on your container. If we had Velcro, I could just stick it right here.
Oh, that's great.
We need more of that Velcro on board, Byron.
Tell you, Mike, we just barely have enough clamps, too. We could use about 5 more clamps.
We put 2 bags of those Lichtenberg clamps on board, I believe, Byron.
And in Byron's hand
also, we're still concerned about your shortage of dry wipes, and wonder if you've used any of the wipes that are supposed to be located in Oscar 8 Alpha, which is an MSDR stowage drawer.
Great Alpha, we might not have checked it tomorrow. We'll look for that.
Yeah, that kind. It's empty. My gosh.
I think there was only one set of them up there, wasn't there? Because we pulled one out of the trash section up there.
I see. I don't know what we're going to do about that. We'll have to uplink you some more dry wipes.
You won't need very many dry wipes for my experiment, Byron. I'm going to try and do it clean.
And Owen, you can remove the ECAS on 22 and start to retract and close.
It's already removed, and we're starting to retract.
Byron Lichtenberg now removing the new end plates.
And Byron, Debbie has come up with a workaround for the peanut butter and jelly sandwich problem that also involves adhesive Velcro strips. Turns out peanut butter should be an excellent substitute for Velcro on orbit. We're planning to fix you an uplink message on the teleprinter. It'll tell you just how to apply it.
Lichtenberg working with the container in which the end plates for Haynes' experiment were stored. Correction, John Paday's experiment. Again, those are the discs between which the fluid bridge is built to study the fluid physics.
Columbia, Houston on air-to-ground 1. Go ahead. Columbia, Houston on air-to-ground 1.
Go ahead, Franklin.
Roger, Brewster, we want to do some propellant management here, and sometime between now and Deidre's LOS, we wanted you to switch interconnects, ohms interconnects, and what we want to do now is to feed from the left ohms, and the procedure is on page 8-4 of the orbit pocket. And after the interconnect is established, we want you to repress the right ohms using the B leg, the leg Bravo.
Okay, we're going to interconnect switch right to left and then repress the right with B.
Roger, Brewster.
And Mission Specialist Bob Parker now in the habitable module.
And Byron, we would like to, for your remaining time, you have about 3 minutes more with John. We have a couple more minutes. We'd like to hear about the long list of items that, that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And we'd like to hear about the long list of items that you want to discuss. And that was read up to you on the last pass by Mike for you to do, and the O2 people would like to talk with Owen.
Can I take my 3 minutes first, please?
And we need to know the ISO depth status.
Okay, the ISO depth is powered on. You want all the rest of the lights?
Yes. Read the light.
You want the manual panel or the manual panel?
We need to know, go to the DPM page. And we want to know the op-nop status on the ISO depth.
It's NOP, negative OP.
Roger, we copy. We'd like to have you op it.
Hey, John, we're set up. We're ready to go.
Yeah, we'd like to have you op it before you leave the DPM, Owen.
Okay, it's opt now, OP now.
Roger, we copy.
And we're also interested to find out if Byron could get a start on that IHF power supply.
And principal investigators here in the Payload Control Center have confirmed through their data from the Space Lab that Byron has completed setup of 329 and has now activated that experiment.
Thanks a lot, Byron. Appreciate it.
Hey, John, just a comment. As I bring the fluid to the edge of your front disc, it fills over an area, I'd say maybe an inch to, well, it's still slowly spreading.
Is that on the front or rear end plate, Byron?
On the front end plate.
Okay, don't worry about that. Now, Byron, can you stop the setup at the moment and take your notepad? It's very simple instructions. Tell me when you're ready to copy. Okay, the first step is to retract both the end plate and the reservoir to equal positions, 40 decimal millimeters. Speed, decimal 20, both front end plate and reservoir. No camera. That retracts to 40 millimeters at zero volume. With that in position now, I would like you to do the settings as follows. Front end plate position 3/6 decimal. Front end plate speed 0.1 decimal 10. Reservoir position 35 decimal 20. Speed of reservoir decimal 12. Camera frame number 40. Camera interval 1 second. Now, be prepared to stop this translation at any time if the liquid looks like overflowing the edges of the cone end plate. When you have carried out this operation, will you then translate at constant volume so that the difference between the position of the front end plate and position of the reservoir is constant and the speeds are constant at decimal 10 and decimal 10 of both front end plate and reservoir. Translate forward with reduced settings until the liquid cone, or liquid dome, I should say, just touches the rear end plate. You then proceed to point beta 2 of the option B and proceed according to option B from point B2.
I understand. Option B, go to B2 and then option Bravo. Is that correct?
Correct. Note that sugar S and alpha are omitted from option B.
Okay, copy.
Thank you very much, Byron. It looks good.
And Byron, here's CPAC.
And Byron, this is CPAC. We've got some input for you on that last run. We've been looking at the chart paper down here, and we see a number of things. The charger output voltage is okay. The heater adjust signal was normal until we came up to T0 plus 15 seconds, when it jumped from the nominal 16 amp command up to 30 amps. The beam voltage did not come up at T equals 0 as we expected, but it did come up shortly after the mod pulse began, and then we got a reset before the mod pulse was finished. We apparently got the EBA shutdown as a result of 3 HVC resets, which occurred within 1 minute. One thing we noticed was a hold command, and like to confirm that a hold command was issued a couple of minutes into the FO after T0.
Roger, that's affirmative. I issued a hold and then an off-sequence start.
Roger, we copy, Byron. And the problems we have, looks like we're going to run MPD sequence on our next go instead of EBA FO. And they're going to be telling you, I guess, about a RAL patch, and our onboard displays will not be valid for you, unfortunately, during that next FO. You copy that?
Roger, understand that the onboard displays will not be valid during the next FO. And you'll have to give us the model number, that sort of stuff, to get the MPD run in.
Roger, we'll come up with that later. It's several hours down line.
Okay, fine. We'll brief the red shift on about that, Roger.
And Byron, thanks a lot. We appreciate it very much.
Sure thing. Owen and I are happy to please. Roger, the fact that the heater current command jumped from 16 amps to 30 amps, would that suggest to you that it might have responded to that and overheated the heater?
We're looking at the various possibilities, but we don't have an answer for that yet.
Okay, thank you.
Roger.
And Space Lab, you all have done a quite remarkable job for this shift. We do have something we want you to look at on the inside of the MPE procedures on the inside front cover, something from the blue team and the red team. And the way of a news item.
Okay, we'll take.
And we have one news item for you. Knowing that you've all spent much time in Huntsville training, you're certainly aware of the rivalry between Auburn University and the University of Alabama. We would certainly sure
we hadn't heard about that, Bill.
Oh, okay. Well, if you haven't, for your information, Auburn has defeated Alabama in the annual Iron Bowl football game. The score was Auburn 23, Alabama 20.
Very good. Oh, we've been waiting for Bill at Slippery Rock.
They were off this week. And guys, the blue team will be talking to you in the morning.
Yeah, thanks very much, Bill. We'll see you tomorrow.
Great job.
This is Marshall Space Lab operations at 5 days, 9 hours, 20 minutes mission elapsed time. We have a loss of signal through the tracking and data relay satellite with Space Lab. Reacquisition of signal will be the next TDRS pass in about 41 minutes. During that last acquisition of signal, we had live downlink television as a matter of fact, during much of that period with coverage of the fluid physics module operations. Byron Lichtenberg set up and actually dismantled the fluid physics module, a previous experiment that was installed in there, cleaned the facility, and set up a new sample. That sample, sample number 329, which is an experiment provided by the Kodak Research Laboratory in the United Kingdom. And during that operation, Dr. John Padet, principal investigator, was in communication with Lichtenberg as he went through the setup, and he started the operation. Also during that period, Owen Garriott spent much of his time operating Experiment 22, the very wide field camera. And at the end of the pass, Roger Williamson, a representative from the CPAC experiment, experiment number 2, debriefed the crew on a previous operation of that experiment, that a troubleshooting operation designed to look at the apparent problem with the electron beam accelerator heater. Just as the pass ended, CIC Bill Bach let the crew know that since they had trained for some time in Huntsville, Alabama for this mission, they might be interested in the score of the Alabama-Auburn game, in which Alabama was defeated by Auburn a score of 23-20. However, the crew feigned ignorance to that rivalry. And alternate payload specialist Mike Lampton provided a recommendation, workaround for the difficulties with making a peanut butter sandwich on orbit. That workaround developed by one of the alternate crew interface coordinators, Debbie Underwood, suggested instead of using Velcro on the sandwiches, they just use the peanut butter, put peanut butter on both sides of the bread and use that to hang the sandwich. 5 days, 9 hours, 24 minutes mission elapsed time. This is Marshall Space Lab Operations.
And this is Mission Control Houston. During the just completed satellite pass, there was one exchange on Air Ground 1 between the Capcom, Franklin Chang, and Brewster Shaw, who's minding the store in the front cabin of Orbiter Columbia. Shaw was instructed to change the routing of the Holmes propellant between the two tanks in the aft fuselage, the so-called Holmes interconnect, and managing the propellant. And that was about the extent of any contact with the orbiter crew during that particular pass. Apogee and perigee standing at 130.5 and 129.1 as orbiter and space lab near the end of the 87th orbit in space. Next orbiter contact will be Goldstone in approximately 38 minutes. At 5 days, 9 hours, 26 minutes, Mission Control, Houston.
This is Marshall Space Lab Operations at 5 days, 10 hours, 1 minute mission elapsed time. Our next spacecraft television will be a live downlink, plus a pre-recorded videotape recorder dump concerning the meal period, which the crew will go through, plus the rotating dome experiment. that 102 vestibular experiment. Coming up at mission elapsed time of 5 days, 10 hours, 14 minutes. That's about 8:14 p.m. Central Standard Time. And that's about 3 minutes from now. Anticipating picking up reacquisition with the reacquisition of signal with the Space Lab in just a few seconds.
Space Lab, Marshal Ops, we're with you for 53 minutes, and good morning to the red team. Good evening to the blue.
The red team's not quite on station yet, but they will be here shortly. They've been around, looking around, seeing what's going on. They'll be on the headset shortly.
Okay, Owen, nice to hear your voice. We understand you had a pretty good day today.
Yeah, pretty good, pretty good. Charles, how you doing tonight?
Just fine, Byron. How are you?
Not too bad. Is John Pat still around?
Yes, I
Yes,
am.
he is, and listening.
Okay, well, we're just cleaning up his run now. I can report total success.
He'll be glad to hear that.
A couple more minutes and I'll give you a full debrief, but let it be said that there is no potential effect whatsoever, and we went straight to, not straight, but through the different points to Hotel 2 without braking, so I had to stretch the catenoid even farther before I got a rupture over.
Copied.
We copied.
May I ask question? May I ask questions?
Go ahead, John.
Okay. First question is, when the zone broke at H, was there a satellite drop? A very small one. You may not even have noticed it.
Yes, John, the zone did not break at Hotel 2. I had to stretch it close to values of about 23.4 and about 20.3 or so, or 20.5, excuse me. I'm sorry. Start again. The final values that I dialed in were 23.6 and 21.7, and it broke just before I got to those coordinates.
Thank you. Can you tell me...
To your second question...
Can you tell me what happened at shape D2 and describe it carefully?
That's Dr. John Petty, PI of 329.
At point B2, it looked very fine. I mean, it was a catenoid, there was axial symmetry, there was no aging, there was no humping or thinning. The only thing that we noticed was a possible, it's very difficult to tell how much liquid goes to the end of your front end plate.
This suggests that there is an aging effect. Now, did you find any aging? In other words, in waiting to see whether the liquid flowed outwards from the neck towards the edge of the plate. Did any of this occur?
There was negative aging. We waited several minutes at each point, or 3 minutes at each point, and there was no aging. When the zone ruptured, there was a very small satellite drop that bounced back and forth between the two larger drops about 3 times and finally came to rest almost exactly in the middle of the zone of air.
Were there, thank you, Byron, were there any air bubbles, small or big?
I didn't see any air bubbles in the liquid.
Thank you. Oh, that's great. Now, can you just tell me what the shape looked like at G Gamma 2?
Okay, at G2, it looked sort of like a catenoid. Obviously, it was a little bit fatter, but just your standard, normal, good old nodoid shape.
Can you tell me where you thought the nodoid neck sort of met the plate? Did it sort of slide out slowly, or was there a sort of a point of almost discontinuity?
Sorry, say again, please, John.
did it look as though you had a thin film on the cone and a neck with a point of discontinuity where the neck of liquid meets the wetted plate? Not receiving you, Byron.
I was just thinking here, I'm trying to understand a discontinuity. Explain it again.
Can you go into the procedures to page 32923? The middle diagram describes exactly what I mean.
Okay, stand by 1 minute here. I'm still trying to...
Space Lab Marshal for Bob if he's on the headset.
Go ahead.
Okay, Bob, couple items for this next run of 22 for you. There's been a change in the coordinates for target Foxtrot. You can expect to see a right ascension of 4.8 and a declination of -30.5. And they'd also like you to begin the sequence 30 seconds early, as you've been doing it previously at 25 minutes, 30 seconds.
Okay, I understand.
And you've got total ECAS this hour of 7.38.
Okay.
And we can continue the reporting with Ulf when he comes on.
Hey, Marshal Ops, Space Lab is firing gets off, you'll be on. Space Lab, Marshal Ops, Space Lab here for 329 PI.
329 PI here.
Okay, John, looking at page 23, it didn't resemble any of those shapes. It was somewhat like the top one. Of course, the top one is quite exaggerated, over.
Okay, in that case, have you any indication what size the neck was in relation to the rear end plate? Just say sort of about half or quarter or 3/4.
Say about a third to a quarter.
Thank you, Byron. Well, look, the rest now depends on the accurate analysis of the film. I want to say two things. First of all, we couldn't have done this experiment without the primary one that Ulf did. Together, they seem to have done just what I wanted and just what I expected. I hope the data show that we have actually measured what I'm trying to get at. I can't thank you enough, both of you, and also the others as well. Over and out now.
Hey, Roger, John. Hey, Roger, the only other comment that I have to make is there, somewhere in that reservoir there's still some bubbles, because I brought the, at the end of the run, rejoined the two columns and brought the front and rear end plates to almost the same position and still had, I'd say, 10 cc's worth of liquid in.
Okay, well, I'll bear that in mind. At the moment, I think I'm correct in saying that we have nothing planned yet for the 5 cc liquid, 5 centistoke liquid. But if we have bubbles, that we can easily cope with them by spinning them out.
Roger. Marshal Ops, Space Lab for the 300 system people. Chuck, you might be able to help on this one.
This is 300 ops.
Roger, 300 ops, PS2 here. On the UHV, the ultra-high vacuum experiment, we have gone down to a threshold of 00010, and we still continue to get UHV, a UHV stop 505, over.
Okay, I copied. Can you repeat, please, the threshold?
Roger, the last one we did was 00010.
I copied.
That exchange between
we'll stop
Jürgen
right
Schuran.
there, and I'll get on with the power supply maintenance. Over.
Yeah, go ahead. Do the power supply, please.
That exchange between Jürgen Schuran, the
Yeah, I don't blame you. Did you get some sleep?
the manager, the material science double
Space
rack.
Lab Marshal, for Bob, as you run this 22 operation, Bob, you can probably expect some sequences that you haven't seen. Don't be alarmed at them, and unless you need to know what they are to come ahead of time, don't worry about it. But if you do, we'll read them up to you.
I understand. We just have the same timeline but a different target, right? Correct.
It's the same target, Bob, slightly different exposure sequence.
Instrument coordinates and the target coordinates to agree, or shouldn't I expect them to agree?
Stand by. Yeah, they should agree, Bob. The RA and the deck that we just read up to you are correct, and you should see them agree.
Okay, but the RA and deck that we just read up are not the ones that the timeline's producing, correct? Is that correct? Guys, modified timeline W to have new coordinates in it or not?
The timeline is patched, Bob.
Timeline is what?
Timeline has been
okay,
patched.
Thank you. Thank you.
We're now receiving a VTR dump of the rotating dome portion of the 102 vestibular experiment series.
Space Lab Marshal, be advised we're looking at a TV dump of an eyeball down here, and it looks fantastic. You can even see the dots on the dome as it rotates.
Okay, that's good news, Chuck.
And Space Lab, the 102 PI tells me that he's 4 feet off the ground.
That's good.
This is Marshall, Space Lab Operations, and the person whose eye we are looking at is said to be that of Owen Garrett.
Ops, this is PS1. Good morning.
Good morning to you, Ulf.
Okay, we are updating the PCAP, and I have the first question for you.
I'm ready.
Okay, question refers to message 089 Alpha. 330, and it's a short run from 1750 to 18 hours. That is for 10 minutes. I think that doesn't make sense because that's the time it takes you to pull out the FPM and install the plates. What is the idea?
Missed the first part of that, Ulf. I understand you've got a question on the 330 run at 1750, but we've had a little comm drop out in the middle.
Marshal Ops, this is PS1. Yeah, the question is whether that makes a lot of sense to run it just for 10 minutes because that's the time you need to set it up and then there's no time left to do some science.
Yeah, Ulf, the run extends to the next page, 18 plus 25.
Okay, I'm not down as far as that.
Okay, if you'd like, we can go through page by page here, and we'll update it along with you.
That's great. Let's do that.
Okay, we'll continue on there, and if the other guys need to break through us, we'll let them. Okay, we're starting at page 11 here, Ulf, and you might make a note up in the upper right-hand corner that you've got 5.22 of ECAS available.
5.22, okay.
You've got a 326 run for you beginning at 11 plus 15.
Yeah, I have that already marked in the PCAP.
Okay, and Bob is going to be running 22 star as per RR 22-6, and he'll use an RA of 48 and a deck of minus 30.5.
Okay, say again the coordinates.
Right ascension 48, declination minus 30.5.
Marshal, this is PS1. We lost you.
Okay, off loud and clear. Right ascension is 48, declination negative 30.5.
Copy 48 and minus 30.5.
That's firm. There's a target change. The new target is 408. A clarification on that target change. Both the target I just read you was for the Faust auto operation in conjunction with the 22 run, and you'll find that in the notes column about halfway down.
Okay, but the target coordinates given for the 22 experiment in the PCAP are 45 instead of 48, and declination minus 30. It's pretty close, but it's not identical.
That's correct, and the ones that I just read you are correct, and the target change refers to the Faust auto operation in the notes column.
Okay, so the only numbers we have to change is really the right ascension. Everything else stays as written in PCAP.
Also, for information, be advised that Experiment 20's active package will be running at the same time.
Okay, I'll write it in the notes.
Still continuing to receive the VTR dump of the rotating dome experiment. The eye that we're now looking at belongs to Byron Lichtenberg. He's wearing a contact lens with special markings for targeting and measuring.
Okay, okay, Marshal. Are you still there?
Loud and clear, Ulf. We're ready for the next page if you are.
Okay, go ahead.
Okay, 326 will shut down at 12 hours and 5 minutes.
Okay, roger.
And Bob's 22 run can continue until 12 hours, 3 minutes.
Okay.
Hey, break, POCC, I understand this 058 door position message is a standard one because of the Trout 21, right?
That's firm, Bob.
Okay, go ahead, Chuck.
Okay, off the minimum ECAS available at 12 hours is 5.228.
You got that?
Okay, now the 201 run at 12 hours 30 minutes is now an oscillopsia run on the payload specialist.
So PS being subject.
That's a firm, and we're going to do it on the. We're going to do ballistic cardiography later on the MS, and we'll talk to you about that later.
Roger.
There's a teleprinter message that explains that. It's teleprinter message 86.
Yeah, I got the note, but I haven't seen the message so far. Is it on its way, or is it already up here?
I believe it's already up, and we also want you to don the EOG electrode during this setup, which will leave it on there for an extra time, which they think will help with the EOG data.
Okay, yeah, we got the message meanwhile. Chuck, I'm going off the loop, Byron. There's something in respect to the MSCL.
Roger.
Marshal Ops, PS2, how do you reach out?
Loud and clear, Byron.
Okay, if we got the 300 systems people standing by, I've got some information on their in-flight checkout and maintenance on the MHF IHF heater supply.
Stand by. They're listening, Byron. Go ahead.
Okay, very good. We took the heater power off, removed the front panel, disconnected Juliet 5, Juliet 7, switched the heater on, did the open and closes, and I'm reading out data 056176, and I'm getting values 001777 and alternating with 1400.
Byron, say again, please.
Okay, reading out the data entry number 056176. I have values that start out with 2 zeros, and it oscillates between 1001400 and 001777.
Thank you. Just thinking about.
And Space Lab, we're ready
okay,
for.
Do you want me?
We're ready for real-time TV from you guys on your cue.
Okay, what is the reason for that? Talk real-time TV for PAO, or is there any science?
Yeah, it's TV 26 off meal period in the mid-deck.
Okay, that's about us then. Show us eating.
Columbia, Houston on air-to-ground 1.
Go ahead, Houston.
Roger, John, we're all set up here for the TV 26 for the meal period TV, and we were just wondering if you were ready for us.
Oh, that's negative, of course.
Okay, we understand that's a negative.
Yeah, I can have it set up pretty quick, but we're not ready right now. I didn't know it was supposed to be real-time TV.
Okay, John, in the meantime, we gotta... Roger, John, in the meantime, I'd like to talk to the Space Lab guys. Is Bob around?
Give me about 30 seconds to close the valve here, Franklin. Okay, he needs 30 seconds to close the valve.
Okay, I copy that, John.
Houston, you may have noticed there wasn't enough time in the timeline to set up that TV.
Okay, John, we understand.
If it would make you feel any better, we can dump the meal prep.
Stand by, John.
Okay, Franklin, I'm ready to talk to you. Let's get the valve closed.
Okay, Bob, first of all, good morning, and Judy is sitting back here in the viewing room. She sends a kiss and a hug.
Thank you. Same.
Okay, and now for the boring stuff. We got a couple of suggestions that might help you guys with the Route 21 problem. It looks like the problems are related to temperature. So we would like to keep the pallet Freon loop as cool as possible. And a couple of suggestions are to minimize Space Lab lighting as much as possible. And we recommend lamp number 6 and number 11 maybe left on continuously. And all the other ones could be on and off as you require. And the other suggestion is just to turn off equipment when it's not in use. so that heat will not be dumped into the H2O loop unnecessarily.
Okay, we'll see what we can do.
Houston, we're now set up to give you real-time TV on the downlink.
Okay, John, we'll go ahead and take that. And John, just a question, which cameras do you have set up for us?
That camera, of course.
Okay, understand.